Well, we've got Nitto tires. Well, but it's not the Nitto drag radio. It's not a competition piece, right?
Right.
So, well, we've got a Bosch injector. Yeah, you got a Bosch injector built for Ford for a GT500 that was meant for that purpose. These were all designed for our purposes, which are the aftermarket, to make a lot of horsepower on alternate fuels. And we've made numerous little changes inside to be able to accomplish that. And that's the thing that we've done a bad job of presenting to the public, right?
Right.
We're an engineering company. We build shit, right? We
Yeah.
try to build really cool shit, and then we forget to tell people that we build really cool shit. So that's why you're here.
Hey, what's up? Ken from Palm Beach Dyno here. I have an awesome video for you guys today, a super rare opportunity. My buddy Paul Yaw, founder of Injector Dynamics, invited me out there and we did a full tour of their facility. If you ever wondered what makes Injector Dynamics different, this is the video for you. Now, this video is over 2 hours long. We cover everything. In fact, at the end, we went to his house, went over his personal workshop, which is just as impressive as the facility at Injector Dynamics. I'm just telling you, it's worth it. Even if you can't watch it all in one sitting, go back to it, reference it, show all your friends, because this is what makes Injector Dynamics different. I hope you enjoy the video. All right, there's the world famous Paul Yaw. We're here at the ID machine shop, or one of many rooms they have here with machines, but this is where a lot of the magic happens. All right, Paul, so what kind of stuff goes down here at the machine shop at Injector Dynamics?
Let me see if I can run through it in order without fucking it up. So if you have a set, here we go, over here. If you have a set of injectors, you're familiar with these we call them top hat adapters.
Yep.
And the purpose of these obviously is to fit the injectors into numerous different applications, and they fit top and bottom depending on the application. And you know, if you're moving, say, 15,000 injectors a month, you got to have a lot of adapter tops. I mean, easily 2/3, probably closer to 80% of everything that we're doing requires an adapter top or bottom. So these two machines, and by the way, we're here at a good time because everybody's left for the day. These two machines, the Haas there and the little Takasawa here, basically run all day long making these adapter tops, all the different sizes and pieces.
And they're running this bar stock through there?
Oh yeah, yeah. So the bar feeder holds 4-foot sticks. So you just load it up, load up both machines, you know, hit the button, walk away. I mean, that's kind of the nature of CNC machines, robots.
And the real cool thing about what you guys are doing here is obviously this is one of a bunch of things you guys manufacture here. Almost everything you guys manufacture yourself.
Yeah.
A lot of companies would outsource something like this.
Yeah.
Yet you're making them here. How many different versions of different spacers do you have? Quite a few?
There's probably a couple dozen. I should know that, but I don't. I'm just, you know, busy with other things. But I mean, we outsource whatever we can. The problem is that there's not that much that we can outsource without me going on a fucking rampage because of delivery problems or somebody just delivering poor quality or whatever the case may be. It's always more expensive initially to do things in-house, but in the long run, you're better off. Now, we did have somebody making these for us years ago when the volume was much lower, and he was doing a great job. It's one of the few times that we've brought a product in-house when we had a good supplier, but we used it as an excuse to buy that machine. That was our first CNC machine. Joe Sawyer was making them for us, and he was doing a great job. But again, we used it as an excuse to buy a machine and to keep it busy, and then we've grown from there.
So that machine, obviously, since this is an integral part, you said almost everything uses adapters. Mm-hmm. That machine only does those?
No, actually, it does a handful of other things too. The machine has a Y-axis and live tooling. So if, for instance, I forget where the camera is. If, for instance, we needed a flat machined on here or a hole drilled in it or something like that, this lathe will do that. So we have some pieces for for a fuel filter, for instance, that require some both milling and turning operations. But this machine does spend 95% of its time making adapter tops. And this one, same thing, the little Takasawa. This one spends probably 100% of its time making adapter tops.
Awesome.
Yeah.
So now that's, you know, it's nothing simple that you do, but that's a fairly straightforward.
Well, this is pretty simple compared to the rest of it.
Yeah, you can say it.
Yeah.
So, you know, but you guys make all sorts of things here. And one thing that you said earlier to me that I really wanted to point out early was one of the major things that makes you guys different is you're helping to engineer the internals of the injector, specifically like on the ID 1700. why don't we talk
You
about?
want to go move into that stuff? You
Yeah.
don't even care about the rest of these machines. You want to?
Oh, that's over
right?
at the other one.
Yeah.
Okay, no, let's talk about that.
I don't care what order.
No, I want to talk about this machine
Oh, okay.
and what you were showing me over
The big
there
one.
next.
Well, it's doing. So this is funny. This is a big machine. It's doing little tiny parts right now. If you think about the, let's say the bowls for the F750 filter and things like that.
Yeah.
Those are some of the larger parts that it makes. But of course, it'll do little tiny things as well. It's not running right now, obviously, but this big monster is currently making.
And I know this isn't an injector part, but we're not talking about just injectors. We're talking about everything you guys do here.
Lots of little things, yeah.
So why don't you tell us what that
Yeah.
piece is?
So it's a screw, can't you tell? We're doing a coil upgrade kit for the Kawasaki KRX, which for you car guys is a UTV. And like a typical Japanese motorcycle, it comes with a pretty lame ignition system. With a stock vehicle, stock tune, pump gas, it works okay, well enough. As soon as you add some boost, you need more spark energy. You have misfire problems. You have to run the gap really super tight. So we're building a coil on plug setup for the KRX and the Honda Talon using a Bosch coil, of course, right? What else will we use? Anyway, to get to the point, to answer your question, there's no place on the valve cover of this with a threaded boss or anything for us to attach our coil kit. So we either sell it with some zip ties or some fucking clay or super glue or something, right? So there are 4 bolts that hold the valve cover down, and they've got a rubber grommet underneath them that seals everything up. So basically we're just remaking, I don't know if you can see that or not, we're just remaking that bolt, that fastener, with a female thread in the end of it. And then we have a plate that mounts the coils for the coil on plug, and the plate just screws down into here. So it's a pretty simple part. And it's, you look at this and you think, well, that's a lot of trouble to go through just to hold some coils down. The problem is that there wasn't really any other way to do it. I mean,
Well, let me stop you there.
Okay.
I guarantee there was another way to do it.
Well,
There wasn't another way to do it right.
I said zip ties, right? That's
Yeah.
one example.
Yeah.
And modeling clay and
And that's
duct tape.
That's the theme here. You guys try to do things right.
Yeah.
The right way. So
Yeah.
that's an awesome piece. And
Yeah,
like you said, that piece is going to last for 10, 20 years. People are going to need that to do different things, hopefully.
Well,
You know,
and that's something that came up when we were talking earlier. The initial investment to do something like this, just to make it faster, it's not a big deal.
Right.
But the initial investment, you say, well, that's a lot of work just to put ignition coils on a Kawasaki KRX, which holds the lowest market share of all the UTVs, I believe. The thing about it is that that's true. And, you know, this may be a financial loss for a year, right? But year 2, year 3, year 4, I mean, I'm not designing shit to throw out there and put on the market for a year and then get rid of it because it sucks and then add something else. We're trying to make things that last and survive. So yeah, it's harder. It's only harder initially, right?
Right.
Oh, that's a lot of work. Well, it's only a lot of work once. Now this machine just spits them out. This will make several hundred of them here over the next few days. And now we'll have a supply that'll last us quite a while. So
yeah.
in the long run, it's actually easier to do most shit in-house and make it yourself because you can get it done right.
Yeah. And you're in control of it at that point.
Yeah. Yeah. Well, so then when you fuck it up, you can come back and fix it without having to call your supplier and say, hey, those 300 parts you made for us, they're wrong because we did it wrong. Now we need, you know, anyway, it's much easier to have control.
Right. All right. What else do we got over in this?
What do you want to see? Oh, you know, speaking of the adapter tops, I'll give you an idea. You asked how many different adapter tops there were. So they just get boxed up here in quantity. And I don't know if you realize this or not, but all the injectors that leave our facility just leave in bulk packaging where they go to T1 in Texas.
Right.
So they sit there on the shelf in Texas, and then the orders get put together based on what comes in. So maybe turn 14, one of our distributors wants, you know, we need 20 4-cylinder sets for a particular application. They'll put the kits together, including whatever adapter tops are needed. So we send all of these to Texas the way that they are, basically.
Okay. So that's a key point to point out to the infrastructure, I guess you would call it, of ID, is you work together with T1 and you're the manufacturing engineering arm and they're the distribution arm, I guess you would call it? Okay.
Yeah, they're the ones that get all the accolades. Like, oh, they're so wonderful to deal with, and we do all the
hard work here.
But anyway, that's it's more about adapter tops than anybody wants to know, most likely.
Right.
But you did say you wanted to start in the machine shop.
Yep.
Did you want to see any of the other pieces currently being built in here?
Sure. What else we got?
What's Asa working on? Oh, that's right. Brackets for the, that's a direct fit bracket for the Nissan GTR.
And this is the top part of your fuel filter.
Yep.
Yep.
Yeah, so this is a bracket to mount it directly to a GTR. I didn't ask you, do you want to be on camera? If you don't, that's fine. All right. So Asa just reprogrammed this bracket just to make the process a little more efficient, and he's just cranking a bunch out. So same thing, we machine the parts here, we send them off to Texas, where they'll get packaged up in their kits. And of course, this is not a complete piece. This is just for mock-up. And
then here's some in the middle of being done.
Yeah. This is called, well, this is after the first operation. So they go back in to get the back machined off. Then they go out.
All done here in this machine?
Yep, in this machine, among many other things that happen in this machine. Typical machine shop stuff. I mean, you have to have tooling, obviously, to get the job done. And by the way, Ace is in charge of the machine shop over here, and he keeps everything nice and neat and tidy. I mean, I knew you were coming, and I said, clean up, but
one thing I noticed is how clean the place is.
Yeah.
You even have like the sticky mats and all that stuff to get stuff off your shoes.
It's super clean right now because I told them you were coming, but it's like 90% this good most of the time because they stay on top of shit. If I take you back and show you my desk, you'll laugh. It's the opposite of this, but anyway, typical, machine shop stuff. Just a nice organized.
This looks like a pretty high-tech room over here.
Oh, every machine shop has to measure their stuff and make sure that it's, what it's supposed to be. That's what happens in here. He is measuring and deburring some ID 1700 internals right now. But basically that's what this room is for, is just measuring, checking, making sure everything is good.
Yeah, that's one thing. This is something that makes your injector, I mean, lots of things make them unique, but what he's doing there by hand, and this is something that, I've known you a really long time. I've been around since before the ID 1700 existed, but I didn't realize that you guys were making every single one of those pieces in the ID 1700s and inspecting it and all that.
By the way, we were going to pretend that we don't know each other, right? Remember that? Instead of letting them know we're old friends. Okay, so the 1700, again, we talked about some of this ahead of time, so I'm going to forget half the shit I said and fuck up the other half, but it's a video, as long as there's something cool to look at. We talked about the support tubes and the valves for the 1700, right? So
real quick, all Injector Dynamics injectors are manufactured by Bosch, but they are 100% your injector. It's not like you're just taking their design and slapping your name on it. That some people have said on the internet.
Yeah.
And this is proof positive here.
Well, yeah, I was going to get to that eventually, but the short story is that the product is completely unique. It was designed in partnership between us and Bosch Motorsport, and literally every other injector that you see on the market with a Bosch name on it is a repurposed factory injector, and they're all the same injector, right? So look at the part number. Well, they get ground off sometimes, but it's all the same injector. This is the only unique piece coming out of Bosch.
Right.
So,
and then this particular piece is something you actually still manufacture here in-house.
This was tough. Okay, so I'm trying to figure out how to move through this quickly without boring people to death. We did the 1050 first, then we moved on to the 1300. Then we needed a higher flowing injector. So I don't remember what our target was, maybe 1650, I think. We ended up at a little over 1700. But here's what happened. We're working with parts that is in Bosch's inventory, essentially, right? We have access to, different valves and things like that. But none of it was appropriate for a 1700 cc permitted injector, right? Because General Motors, Ford, BMW, they're not calling Bosch saying they need a 1700 cc injector. And so there were a number of changes that we had to make internally to get the flow rate and make the injector actually usable. So you're going to have to probably do this yourself to be able to focus in, but this is a valve. Or maybe you could focus on that.
We'll get some close-ups after.
Yeah, okay. So you might notice that there are 4 holes in that valve. And I don't know if you can see that or not. But the short story is, when the injector is assembled, we have 2 pieces here, like that. And there's a spring that presses the valve down onto the seat. Presses it down about 8 thousandths of an inch from that metallic piece on top. The fluid flows down through this piece on top. It flows down into this passage, out of these holes, and then around the ball, finally to pass through the seat and make it into your engine. So from the factory, there's 2 holes in there, 2 flow passages. And that turned out to be one of the restrictions inside of the injector that we had to work with. So essentially, we use a wire EDM process to add 2 additional holes there to increase the flow path, obviously. And then to take that a step further, we also had control over the valve seat. And by the way, again, I don't know how well you can see this, but that's a ball, and it has some flats on the side. That's to allow fluid to flow by. But the ball basically sits in a funnel, right? That's the best way to describe the valve and seat. Drop a ball into a funnel.
Yep.
And so that seat is something that we had control over, the angle of the seat, the orifice diameter on the outlet. So those changes were made to increase the flow, along with elimination of the filter that was in there. The filter was quite restrictive, so we had to source a completely different filter because, believe it or not, that was a restriction to flow. We went through all those steps, got the flow that we needed with a lift of about 0.08 of an inch. By the way, that's why filtering is important, because this valve literally only lifts 0.08 of an inch, or just a hair less than that. The problem we had is that we didn't have a strong enough magnetic field, because the further we move the valve away from this piece, which forms the electromagnet that draws this part up to open the valve, the further away you get, the less force you have. So now we had a problem where we had the flow that we needed, but we didn't have the response that we needed. So at, say, 3 bar, 14 volts, it worked just fine. The voltage goes down, maybe 10 volts during cranking, the injector wouldn't open. We want to run it at 4 bar, 5 bar, 6 bar, the injector won't open unless it has real high voltage, because we don't have enough magnetic force to pull the valve open. So what we did is we used I'm trying to decide if I can tell you what this material is. Well, it doesn't matter. Let me just say that this is not the standard material that's in the rest of the EV14 production line. It's a material designed specifically to have very good magnetic properties. And from memory, I think by making this piece out of this material, we increased the magnetic force by about 20%. Again, it's from memory. Could have been 25%. That was a lot of years ago. So the point is, we manufactured this piece, which we call the support tube. We modify the valve, and then we send these pieces back to Bosch, and they build them into the injector.
And the support tube, like you said, you have to visually inspect every single one, right?
Yeah.
Is that what this machinery is for?
Yeah, so that's what this is for. And here's what this is about. When I first told people that we were making and modifying pieces and sending them to Bosch, and they were building them into the injectors, they didn't believe us, because it's, not exactly typical. Yeah, so we had to convince them that we were capable. I mean, we had a shop tour. We had engineers here from Germany and from the US, and they basically came and stuck a microscope up our ass to make sure that we weren't going to embarrass them. Right? So one of the things that was required for this project is we had to do 100% inspection on all these parts. So it wasn't a situation where we could just machine them and send them and have so many failures. That's
Or
not
check
how they,
1 out of 10 or 1 out of 100.
that's not how they do things.
Yeah.
So the video inspection equipment that they said we were going to need to do that was $280,000. Like, hey, I'm not General Motors, right? This is a performance aftermarket. That ain't going to fly. So we worked with them for a while, and the short story is we do a dimensional check on these with, a set of, with a micrometer, like you would anything else, every single one of them. And then because this is hard to machine, it is prone to cracking during machining. If any part of the process is wrong, if the tooling gets dull or anything like that. So literally someone has to sit here every month with every month's supply of 1700s and inspect both of the inlet and outlet diameters for cracks through the microscope. So it's a pain in the ass, but I didn't have to spend 280 grand for video inspection equipment.
And, what, obviously you have to check them, but is it like, how often do you actually find a crack?
Well, the better the machining process, the less cracks you have, right? So I would not be at all surprised. I haven't tracked this in quite some time, to be clear, but I wouldn't be surprised if we have months that go by without any failures.
Okay.
Right? Because what happens is over time, you start to dial in the machine process. You start to understand when you need to change tooling, feed rates get dialed in, coolant flow, things like that. But at the beginning, yeah, there were a fair amount.
Yeah.
We've thrown a lot of shit away, maybe more than a little.
That's
yeah,
awesome.
but that's just how it goes. But yeah, the 100% inspection was an absolute requirement, and I like it. And we ultimately have 100% inspection on everything we do here.
Yeah.
Filters, everything. They get, like for instance, a fuel filter, something as simple as that. Every single one of them gets leak tested, right? So everything gets 100% inspection.
Well, that's
because
really,
you look like a fucking jerk off when you put something on the market and it doesn't work.
and it's not even just inspection. You guys break in every set of injectors. Is that
Yes.
right? Yeah. Okay.
What's so surprising? But hey, wait, don't run away. How often do you find a crack in one of the support tubes? He just asked, and I said it used to be a lot, and now it's not very much.
Very little now. It was
1 in 1,000, 1 in 5,000. Just guess.
I would say
just
one,
curious.
1 in 1,000.
No, okay.
About.
Well,
Yeah,
that's not zero, so
Yeah.
it could be better.
So we got all the ones that we wanted to separate from all the from any cracks, anything that's going on. We got,
And it looks like you got,
and there's not really that.
That's my
much.
favorite label right
Yeah.
there.
and they're
Smashed.
categorized. So
Smashed.
some of these could be like an old tool causing the problem. So
It
that,
could.
yeah.
Well, the welds on that
Yeah.
ball that he was
Yeah.
talking about, even that weld could it just something happened. It just the machine. Anything could have happened. And that's why we inspect every single one of them, is to be able to make sure that we can take those out from all the actual successful.
Here's what this is about. These labels, we use these labels when we want to fire somebody. We say 27 slags, 32 scars, 42 that were pitted. Fuck off, have a nice day. That's what those labels are for.
All right, Paul, that says bad. I don't think that means badass.
No,
What's going on there?
that means bad. That's what happens early in the production process. They've all got a mark on them. Oh yeah, I can see it. It does look kind of nasty.
Is that
Anyway.
what the X is showing what's wrong?
Yep. Could be just a cosmetic blend, but
So
it happens often when we start something new. It's like you end up with big piles of shit, and I try to not look when I walk by, but once you get it going, you get it dialed in. That's pretty typical.
Yeah, but even if it's a cosmetic blend, you're still pulling it out. That's, you guys are super proud of what you do here, and that's what's important. I mean, some companies don't even do quality control. It's like, well, the machine spit it out, ship it. The second.
Yeah, but to be fair, that says a lot more about them than it does us.
Yeah.
In other words, what I mean by that is we're just doing what a manufacturer should do. And the example you offered is someone just sucking really bad.
But
and I know you're offering that up because the performance aftermarket has a lot of that, but
That's what
we're not special. We're just competent. You didn't want me to say that, did you?
Well, I think it's good to be humble, but
No, I'm not being humble. I'm trying to just be objective.
yeah, you're being objective, but you're not really being fair to yourself, because the performance aftermarket is lackluster as a rule of thumb, in my opinion.
Can I make a joke about winning the Special Olympics?
Sure.
I think I just did. No, when I was a kid growing up, you didn't half-ass anything.
Yeah.
Right? My dad will see this eventually, and he'll be thinking, damn right.
But no, I think that's important. I mean, I deal with a lot of aftermarket companies, and some of them are really good, but a lot of them are not.
I mean, we do take a lot of pride in it, and we work our ass off, but there's a certain level that I would just say competence and is required. And if we exceed that by some amount, that's great. But I mean, we're not SpaceX. We're just guys doing
And I
good,
guarantee
high quality stuff.
SpaceX has a rack of bad shit too.
And they don't send it out. Well,
Exactly.
see, the difference is that you could sell something and somebody in the aftermarket might not notice, and you fuck up a rocket that's coming back down.
Right.
And they do that fairly often, don't they?
Yeah. Yeah. Right.
It's just another one of the same brother vertical mills, mostly used for prototyping, sometimes for production. These
Well, you had mentioned this. This was
that's
a pretty
true.
cool thing.
Actually, this got done on the other S1000, but this is part of the UTV fuel delivery module, which we'll see when we go down there. And we had to have pieces of tubing that were coped almost, well, not almost, but exactly like if you're building a roll cage or something like that.
Right.
And so my intent when I dreamed this thing up originally was that those would all be laser cut. And we had a lot of problems trying to get them laser cut. We just couldn't get, we couldn't get anyone to offer what we wanted in terms of quality and price. So we just came up with this idea to clamp them in the mill and, and do the coping in the mill. And it ends up being far less expensive than anything anybody was going to do with a laser. And again, because it's here, we have complete control over it.
Yeah.
So just drop them in the mill and let it rip.
And I mentioned this to you earlier, you're using Brother machines, which I'm not a machinist, but it's not a common brand in machine, or is it?
Medium.
Yeah. What made you go that route with those machines?
That's a good question.
other things?
The local company, the supplier for them, Yama's in. And the reason, let me think, it's been a long time. The very first one that you saw over there is actually a 5-axis machine, a little tiny 5-axis machine. It's real fast. It'll only do small parts. And I think the determination was that when we did the IDF 750, that filter, that's a fairly complex piece.
Yep.
And to manufacture it for a reasonable cost, we needed a 5-axis machine. And brother just happened to have this little tiny high-speed 5-axis machine. We had a local distributor that carried it, and it just worked out okay. It's been a workhorse. It works great. So we ended up buying, 2 more of their machines. We actually bought this one used, but they're good machines. I like them quite a bit.
And over here, you showed me this earlier too. This is,
Bandsaw.
you could
Real exciting.
You could probably have somebody stand here and cut metal all day, but this takes care of it for you.
Yeah,
Use this to
basically,
cut down all your stock.
you just grab some stuff off the material rack. Like, for instance, this is, it keeps coming up, the F750 filter. This is what the top part is built out of. I think when it goes in the vise, it's got to be about 4 inches long. So you can just take this entire stack, feed it in there, and it'll knock them all off at 4 inches. Then you have your parts to start your base machining. But it's CNC controlled as well, so it just does the work. You load it up and go, just like the machines themselves. So nothing too exciting.
Well, sometimes the least exciting things are what? Oh, look at this old machine over here.
Yeah. Well, I mean, it happens in any machine shop where sometimes you just have to do these little tiny projects,
Yeah.
So basic stuff, chop saw, and I think they got a lathe over here. We got the lathe at my shop. No, I guess they don't have a manual lathe over here. I couldn't remember.
So something like that.
There's that little pile of shit. I don't even know what they use that for.
Look at that thing.
By the way, when you hear me say that, you're thinking, how do you know what goes on in your own company? Well, once you grow to a point, you don't know every little detail about what's going on, which is a little weird for me when I wander through sometimes. Like,
yeah.
what the fuck is that?
Yeah, no, that's this happened with me too.
Yeah.
It used to be I knew every customer that got tuned. Now it's like I don't even know which car that is.
And then the worst part is when you delegate and things go bad.
Yeah.
That's tough. That's been the hardest thing for me. Because actually I made a Facebook post one time that said, if you own the business, it's your fault, because even if you didn't do it, you hired the dumb motherfucker that did, or you hired the dumb motherfucker that hired the dumb motherfucker that did. Like, no matter how you go about it, when something gets screwed up at your business, you made a mistake. And for me, those mistakes have been delegating and not understanding fully what that particular person was capable of. And there's a bunch of great people working here, but I forget that I've been, cutting, welding, machining, assembling shit for 35 years. And I forget that a 30-year-old guy has a little bit less experience than me. So I throw some complex task at him and say, just go ahead and get it done.
Yeah.
Treat them with respect, give them all the room to run. And then they bring it back and it's not right. And then I'm furious. And then 2 days later, I realize, of course, they don't have your experience. So I don't know if you're going to leave that in there, but that's been my biggest personal shortcoming in running a business, is saying, no, just go do this.
Yeah. And having the perspective to realize that they don't know, like, it's easy for you to look at it and know exactly what's wrong,
right,
where they went wrong and all that. And, but there was a time when you didn't.
Right, exactly.
But you're still who you are now. So they're going to be someday, maybe.
Right. The problem is not that they suck or that they're fucking stupid. It's that they're 35 instead of 55. They're in the gray area. Like, they haven't stepped on their dick enough to realize, oh, that's a bad idea. So that's been a big problem for me.
Speaking of that, how many people do you have here, roughly?
It moves around a little bit, somewhere over 20.
Yeah.
And then I never know the exact answer to this. How many people are at T1 in Texas that are required to make the rest of this happen? But roughly, it takes about 30 people total to keep Injector Dynamics rolling.
Yeah. And that's with the injector business. And then now, so the side-by-side stuff, that's under the Injector Dynamics name or under Yaw?
No, it's going to be under Yaw Power. The reason is, a coil kit, right?
Yep.
A set of upgraded ignition coils for a Kawasaki KRX.
Right.
First of all, everybody wonders, who the hell's Injector Dynamics? And then Tony's there in Texas going, I don't give a shit about a UTV. I build 2,000 horsepower Lamborghinis.
Yeah.
Right? Fuck your little 100 horsepower buggy. I don't care. So all the UTV stuff, fuel specific UTV stuff is Injector Dynamics. Obviously, we're a fuel delivery company. All the non-fuel delivery stuff is under the Yaw Power name.
Okay, so the fuel pump stuff is Injector Dynamics.
If it's related to fuel, it's Injector Dynamics.
Okay.
Because that's what we do. We get fuel in engines in hopefully the appropriate amount.
Right. Yeah. All right, we're over in Injector, Building 3, where a lot of the injector stuff goes down.
This is what I'd call the clean part of the business. I mean, it's
Over
obviously,
here, look at how this is how
Yeah.
important the cleanliness is.
well,
Again, it takes all the dirt off your feet.
yeah, those mats are pretty cool. I don't know if you can tell, but you see this has a number on it. If they get dirty, you just peel them up. Get to the
Oh,
next
okay.
one.
Very cool.
So because we're in Arizona, there's just dust everywhere. And obviously this isn't a real clean room. We don't need real clean room quality. We just don't want to be,
But it helps.
yeah, we don't want to be working under a tree in the backyard in a dust storm.
Yep, absolutely.
So everything clean happens in this building, meaning the injector testing, Eric's assembling, pump controller, filter assembly, fuel pump assemblies, everything happens in this room, basically. Everything not dirty, white walls, right?
Yep.
Yeah.
Why don't we go over like a beginning to end with how the injectors
See if I can remember this. Like I said, I tend to get separated from some of these processes over time. In fact, I was talking to somebody about injectors on a podcast a couple months ago, and he was asking me questions, and I was afraid I sounded kind of like an idiot because it's like, fuck, I haven't thought about that in like 15 years. I was having to dig back a little bit.
Yeah, well, it
But
happens all
anyway.
the time. People ask my opinion on
Yeah.
car stuff, and it's like, what combo, this or that,
Yep.
or pulley? I'm like, dude,
You don't remember.
I don't know.
Right, that was 3 years ago, 5 years ago. So this ugly contraption, everybody's seen this because we made a big deal out of this in the early days. And by the way, the early days for us were basically just trying to show the public that we weren't doing the same shit that was going on out there. God, this machine's 15 years old at least. So here's the deal. Every mechanical device undergoes a break-in period, right? So if you were to buy a brand new car, do a leak down test, assuming leak down tests were super accurate, you do a leak down test, compression test, run the thing for 1,000 miles, do it again, you're going to get different numbers. There's an initial seeding in that happens initially. And in this case, we've got that ball from that valve that I showed you that's slamming down into that funnel, basically. And it eventually kind of beats itself into that surface, and the injector characteristics change ever so slightly during that initial process. So what this machine does is run 48 injectors at 100 hertz, which is the equivalent of 12,000 RPM, at 100 psi. So it's slamming the, maybe it's 75, might be 75, I don't remember. I'm afraid of getting it wrong and somebody catching me and saying, no, you lied. For a half an hour. So we just beat the living shit out of it.
If somebody corrects you, you can give them a gold star.
There you go.
Yeah.
That's right. It's the internet. Well, it'll be one of these guys. I'll hear about it. Like, hey, what the fuck are you doing? So basically, we put the injectors in here. We just beat the living shit out of them for a half an hour before we test them. So they get beat up here. Then they get serial numbered on the laser. And because they're gone for the day, you don't get to see the laser working, but you can kind of, everybody's seen a laser, put a serial number on a part. So we beat them up here. The reason that this big bulky thing fits inside of here is that you do not want to hear 48 injectors running at 12,000 RPM at 100 PSI. You really want to hear this?
Yeah.
All right.
Yeah.
It's so irritating that we roll it in there just to keep the noise down. I mean, it's nasty. It's really nasty.
Yeah, I have heard it. I think you did a video in the past. It might have been before you got that enclosure because I was sitting out in the middle of the
Oh
floor.
yeah. Yeah. It's horrible if you're working back here.
Yeah.
It's probably even horrible now if you're working here, but yeah, that cuts it down.
So after this process, then they get serialized. How does and then every injector gets tracked by the serial number?
Oh yeah.
Okay.
Yeah, literally everything. I mean, you can't match them if you can't identify them, right?
Right.
So
when you get an injector back, you could look it up and
we can pull up the old test data.
Yeah,
Yeah.
the original test data
Yep.
and see where exactly it was.
Yep. So they get beat up over there, and then they get serialized on one of those 3 lasers over there.
Is this how you kind of transport them around?
Yeah,
Yeah.
in the racks, because the injectors drop right into the rack. It
Oh, wow.
works out,
That worked out
pretty
perfectly.
well. Yeah. So it goes into 1 or 2 flow benches here, and basically they all get tested and characterized. All of the injector characteristics go into a database, and then after the batch is done, we've got to match them up. So this is where things get not complicated, maybe just a little bit ugly. So what happens is, let's say we run a batch of 1,000 injectors. When we want to match them up into sets of 4, 6, 8, whatever the case may be. Out of that batch of 1,000, there's going to be, let's say 2% that we end up never being able to use. maybe a little more, because it's completely outside of our window, our specification for what our injectors flow. So those kind of get shoved off to the side. Eventually they get marked as out of spec, and they end up being gifts for our friends. Hey, I need some injectors for my car. You've got to say, yeah, okay. So it says out of spec right on it.
Yep.
And they're either high flows or low flows, but they're properly matched. There's nothing wrong with the quality, but they don't fit the window that we specify. And that's important because we're sending injectors to people doing kits. I mean, that 1,000 horsepower Mopar crate engine, remember they did that a few years ago? Well, that used 1050s, right? So we can't just send them a bunch of random shit and have them install those in 1,000 horsepower motors. So we have a fairly tight window. So again, some of them get thrown away, and out of 1,000 injectors, hey, Eric, give your headphones on. Hey, out of a batch of 1,000 injectors, how many get matched up out of just that batch? 800? Okay, let's just call it 850. So now we got 150 injectors that they're fine. There's nothing wrong with them, but they don't match up into sets, right?
So they're within spec, but there's not enough of them to make a full set.
Right.
Okay.
Right. And so then we come over here into what's called usable spares, right? There are also spares that aren't usable, which are out of spec.
Right.
Like you said, you got a set of those. Hopefully you got them for free.
Yep.
Yeah. Okay.
Yeah,
good.
you gave them to me.
Okay. So we have usable spares, and these are all recorded in the system. So out of that batch, maybe you use 850 out of the 1,000, and then you've got 150 left. Well, out of that 150, you may be able to use another 100 of those using some of the usable spares from previous batches. So they're constantly cycling through. That's the way that whole game works, to get them all matched up over time.
Now, I'm not going to put you on the spot. Wait, actually, that's what I am doing.
Yeah, that's your
But
job.
you don't have to give me the exact.
Right now, that's your job.
You don't have to give me the exact number, but say a 1,700. What would be considered out of range? Like how plus or minus?
Plus or minus 2.5%.
2.5%. Okay, I don't know if you said that.
Now that's not the matching within a group.
No,
That's
just totally.
Yep.
So, under 2.5%, and then those can match together. Above 2.5%, those can match. But if they're higher or lower than that, then those are the giveaways.
Yep. The giveaways or get sold cheap.
Yep.
Depending on who it is and
Yeah.
what kind of a mood we're in.
Right.
Yep. So, and the usable spares, by the way, also get used for warranty replacements, because one of the things that happens with injectors in the market is that people build a $25,000 engine and they put $2,000 worth of injectors on it, and then they buy the cheapest piece of shit fuel filter they can find, or they don't install a fuel filter at all, or they don't clean out their fuel lines before they put it together. The first time they fire the car, all that shit ends up in the inlet screens in the injectors, right?
Yeah, I think that's one of the most overlooked parts of this whole thing. Because you'll get the people that are like, no, I need ID, and they're spending the money on the ID, the good stuff.
And they fill them with garbage.
Or they got like a stainless steel fuel filter
Yep.
or something like that, which is total garbage.
Yeah.
I mean, I assume you have the same opinion on most of those.
We have the test data.
They don't filter anything.
That's right. That's why. I should post that data. That's why we ended up doing the filter initially.
I got
something Bosch.
I got a funny story. I had a customer who.
No, wait. This is about me.
Okay.
No, I'm kidding. Go ahead.
It's about your injector stuff. And he's like, he wound up with dirty injectors, and I was like, what fuel filter you running? Blah blah blah, Micron stainless. I go, no man, you need a micro glass. Get the ID filter. I did, but it kept getting clogged.
Well, then you got a problem.
Well, that's the point of the filter.
Good point. Yeah.
Where is that stuff going right now?
Right.
It's in your injectors.
In your injectors.
That's why they don't open.
And again, the 1700 has a lift of just under 0.08 of an inch. If you go all the way down to the 1050, the lift on that is just under 0.04 of an inch. Think about that. That's as far as your valve is opening. That means if you have a 0.005 diameter particle, it ain't going to make it through a 1050.
And to put that in perspective, that's like a couple human hairs, maybe.
Oh God, I don't know.
I think a human hair is like a couple thousands.
I don't know. I couldn't even get. I'll screw it up.
Yeah, but something that small.
But if I say
tiny.
microns instead of thousandths of an inch, nobody will know what I'm talking about. So I can just make numbers up and nobody will catch it.
Yeah.
Pretty much all the injectors that come in that are screwed up are because of lack of filtration. So the filters are clogged full of shit, and then some of the stuff makes it through. I say the filters, I mean the filter that we install in the end of the injector. That's a 35 micron filter. That's basically there to just catch fucking rocks. I mean, that doesn't help the injector. If it was if it had a high enough filtration level to actually protect the injector, it would clog up in a week because it's so tiny. Right. So we get these injectors in, and the filters are clogged, and the moving assembly is just beat to shit because it's had a bunch of crud run through it. So that's a pretty big deal.
So it's saying ready for filter check. What exactly is the filter check? Like,
Hey, Eric, you want to chime in? So by the way, we mentioned we had to use a different filter in the 1700 because it was fairly restrictive, the factory filter.
yeah,
One of the things you should know, back to the concept of these being a unique motorsport injector, not just whatever's on the market, is that the filter inside of all of the EV14 injectors is non-replaceable. So the filter gets pressed in, and then another portion of the sleeve goes in behind it. They can't be replaced.
right.
So they were reducing flow, but you can't change them. So we have a replaceable filter in these so that we can, one, protect the injector, but also if your injectors come in all clogged up because you didn't have the right filtration, we can pull those out and hopefully, keep the injector alive.
When you're doing all this stuff over there, you don't have the injector.
No, the filter is in them when they get flow tested.
Okay, they are.
Because it does have an effect on the flow. Again,
That's why I was asking.
We've been talking about the 1700 so much. By the way, have I mistakenly called it the 1750 a few times?
No, I don't think so.
There's a reason for that. There's something a little bit new on the way.
I was scared to say 2600 because I'm like, 2650 or 26?
let's just,
Was it
so,
a 2650 at one point or no?
well, that's about they flow.
Okay.
But anyway, back to the 1700, which I'm using as an example. Even the new filters that we have made, which have more than twice the filter area, it represents a flow restriction of about 0.8%.
Oh, okay.
Yeah, so that's a clean filter, right?
Right.
So it doesn't take much to make a mess of things and ruin that.
So the filter is installed during manufacturing?
Yes, no.
Or you
We
do that
install
here?
filters here.
Okay.
Yeah, because the production line at Bosch isn't set up for that. So everything that happens there, man, you'd have to see the production line to understand. I mean, it's not like a handful of guys wandering around taking the time to do a nice job. It's robotics and, so they're not going to build a station to install our filter.
So you're installing them by hand?
Yeah, right there on the arbor.
Right.
Price.
So,
Yep.
we've already gone over quite a few steps here that are hand done on every single injector, especially the 1700. The parts that you manufacture, the parts that you modify, all those get inspected, every single one. Every single one, you're installing a filter. So, for instance, if you're buying a competitor's injector out there, which I'm not really sure they're competition, but you know what I mean, like an alternative injector, I guess.
Thanks, kid.
Yeah.
It's very real simple. Obviously, they would decap these first.
No, when you say decap, people are going to think you mean cut the end off the injector.
Take that out. It's literally just taking these caps off.
Yeah.
Put it in a separate bin. And once you're done with that, super simple. This looks very basic, but Evan and Kacho spent a lot of time on this to make it easy. You just pop it in, just make sure everything's pretty straightforward, nice and flush. Pretty much it. So
That's pretty high tech right there.
And then you have a special like puller tool to pull it back out if it needs to be changed.
hardly ever have to because it's usually just service that has to pull the filters back out. If they come in, the filters look clogged. Nick will go pull that filter out, clean them, put a brand new one in afterwards, and that's the only time we really have to pull it back out again.
Let me tell you about the original filter removal tool that I built. This is pretty fucking high tech. Take a number 8 screw, wood screw from Home Depot, and you grab it with a pair of vice grips.
Yeah.
It works fucking
We
great.
still
Yeah.
might have that lying around.
Yeah, probably.
The alternative injectors out there, they're all just using a standard Bosch filter in them.
Yeah, because it's not removable.
Right.
Yeah.
I mean, that's seemingly a pretty huge difference that I've never even really.
Well, there are actually lots of little details inside of the injector. Oh man, there's so many little things. Standard EV14 has an additional ring filter on the valve itself, by the way, where we add those passages
Yep.
to the 1700. There's a ring filter there. We don't have that in our injectors. The ring filter's gone because it's a flow restriction. And by the way, that ring filter. So you understand, the ring filter exists in case there's any galling during the production process. So Bosch measures failures on injectors, not in how many failed parts per 1,000. It's parts per million. I'm not exaggerating, right? So if in a million injectors, they had 2 of them where they had some galling and a little particle drop down in and create a problem for the valve. They find out they can put a ring filter in there that costs them, I don't know, probably $1 per 1,000 filters, right? They add that, and that improves their production process.
Right.
But in the aftermarket, we're not playing the same game.
You don't
we're all about flow and making shit happen. And
Right.
then, the main filter that goes in the top, that one we install there, that's also not to protect, well, it is to protect the injector, but the assumption is at the OE level that you have proper filtration at the pump and somewhere in between the pump and the filter. That's just there in case of manufacturing accidents, more or less, right? You install the fuel lines on the car, there's a little bit of crud in there. That's what those filters are for. They're just there to catch the big stuff in case something really ridiculously oversized ends up in the system.
Yeah. And speaking of filtration,
It's a lot of talk about filters, isn't it?
well, I'm going to keep talking about them.
Yeah.
Not the same filter, but
Yeah.
the biggest issue I see is even placement of fuel filters. Like people just put it wherever they want, and obviously the closer you put it to the rail, the better, right?
Yeah.
And why is that? It's
Well,
partially-
look at a production car. They typically don't put them up near the injectors. They
Right.
put them at the back because, everything's installed in a clean environment.
right.
Not the case for us. You've built plenty of fuel lines. What did you cut your braided stainless line with? A cutoff tool?
Yep.
Right? And then you rinsed it out in your solvent tank.
Yep.
Hopefully you got it clean, sort of. That's the after.
Oh wait, rinse it out.
Yeah, right. Are you blowing out? Whatever. Anyway,
No, just turn on the fuel system.
yeah, exactly. Yeah, we call that pre-fucking the filter.
Yeah,
Right?
yeah.
Anyway, God, I lost my train of thought now. You screwed me up.
We're talking about placement of the filter.
Okay, so anyway, the placement of the filter is not critical if the whole system is clean. But if your fuel lines are full of crap or they're coming apart because they're cheap garbage fuel lines and you're running E85 in there, by the way, we see a lot of that. Filters just full of bits of rubber coming apart from the inside of the lines. Get the filter as close to the injectors as you can, right? If the filter's at the tank and the injectors are up here and the line is decomposing between the filter and the injectors, it doesn't do you any good.
Right.
So you can say, well, I had a good filter on it. It was 15 feet away, but I had a good filter on it. We're like, well, the injectors are full of shit. It wasn't born there. It had to come from somewhere.
Yeah, and I'm guessing I see a lot of black gunk in the injectors, and
That's the lines.
That's the line coming apart, which is, that's a case of somebody using the line that's probably not the right line in the first place.
Right. The Teflon line stuff is by far the best. And it's a pain in the ass because it's very rigid. It's hard to work with. It kinks real easy. But if you're running any alcohol fuel, that's absolutely the stuff you should be using.
Yep. This is the laser machine. I know it's not running
That's
right
one
now.
of three. Yep.
This is, we're not going to see in there, but are these already lasered or not yet? No, not yet. Yeah.
Ready. That bin says ready to laser. Yep.
Oh.
And then these automatically consecutively serialize the injectors.
Yeah, and for
Right,
those,
so you just put a new one in, and the next one is a higher number by one.
and for those people that don't know, I knew this, but I think I forgot, and Paul pointed out to me earlier. If I can get this to focus.
Good luck.
Good luck, right?
Oh, the D embossed.
Yeah,
in
the
there?
D embossed.
Yeah.
It doesn't look like you guys. I haven't really seen any issues with somebody. It's not very common for somebody to try to pass off ID or their injectors as ID injectors, but that's one way to know for sure.
Yep.
I've had some shops install it's usually an installation thing, not usually like, oh, they bought injectors and they thought they're ID and they got shipped to them as ID, but it's more like, yeah, I'll put ID injectors in your car, and they put something else in.
Oh, no shit.
Yeah.
Oh,
yeah.
how nice.
Yeah, not super often, but usually when we have an issue, and I'll look down in there and I'll be like, oh, wait, that doesn't look like an ID.
No shit.
Yeah.
Interesting. So I don't know how well you can see. Well, I can't see shit without my glasses. I'm getting old. But basically that Injector Dynamics, that logo, the big D as we call it, is part of the mold. And so as we were doing all these injectors, we had to pay for new molds anyway because we wanted a specific connector, body length, all of that. So we just paid to have our logo put in there as well. So by the way, even the molds that these injectors come out of are unique to Injector Dynamics. And by the way, you remember in the early days, or maybe you even deal with this now, where you've got something in a car that flows 1,000 cc's a minute and you need to step it up because you're changing to ethanol or something like that. Now the new injectors are a different length and they take a different connector and all of that. You might notice that all of our injectors are exactly the same length with exactly the same connector because they're all a unique piece. We got to design from scratch instead of saying, well, this part from a Ford works pretty well, and this injector from Polaris works pretty well and flows this much if we cut the tip off, and that's not what we're doing.
Right.
So we have a unique piece. And by the way, back to this filter, you'll notice that, well, you won't notice, you have to cut one apart, but the stock filter in a standard EV14 has a brass ring, this compression ring right here that makes it a press fit.
Uh-huh.
This is all stainless.
Okay.
So we don't have to worry about that. Now there's a piece in there, it's a roll pin that we use to, or that is used to set the spring force that holds the valve shut. That roll pin typically is made of brass, except in our injectors it's made of stainless steel.
Okay.
Right. So lots of little details like that. The lack of ring filter, the ability to specify lift, spring force, valve angle, valve outlet diameter, filter arrangement, all that stuff is all unique to what we're doing. And one of the things that I guess I would try to point out is what's the hot ticket drag radial these days? What is it?
Still Mickey Thompson.
Still, okay.
Yeah.
Well, that doesn't work for me. Let's just say it was a Nitto, right?
Okay. Yeah.
Okay, so here's why it works. Well, we've got Nitto tires. Well, but it's not the Nitto drag radial. It's not a competition piece, right?
Right.
So, well, we've got a Bosch injector. Yeah, you got a Bosch injector built for Ford for a GT500 that was meant for that purpose. These were all designed for our purposes, which are the aftermarket, to make a lot of horsepower on alternate fuels. And we've made numerous little changes inside to be able to accomplish that. And that's the thing that we've done a bad job of presenting to the public, right?
Right.
We're an engineering company. We
Yeah.
build shit, right? We
Yeah.
try to build really cool shit, and then we forget to tell people that we build really cool shit. So that's why you're here. So I was talking about unique things in the design, and this one is almost pointless, but since you got me bragging about this, I'm going to do it anyway. So because almost all of our injectors are used with boost, there's something that came up here where under boost, there could be a tiniest bit of leakage between the what they call the overmold, the plastic part, and this chrome plated piece here on the bottom. If we could take one of these apart, you'd find that just about 1.5 millimeters up inside of there is an O-ring that only exists on some of these injectors, and that's only injectors that are meant for boosted applications.
Oh.
And that's to keep from getting fuel seepage around here, and that costs us like a whopping 1.2 cents per injector to add it. But it's just another little detail. It's one of the things that we get to account for. I mean, even things, well, that's pretty much non-critical. I was going to talk about alignment tabs and things like that, but it's not that big of a deal. The point is simply that this is a part engineered specifically for motorsport, for the performance aftermarket, right? It's not a piece that was designed for spraying into the crankcase of a Polaris 2-stroke that, flows 1400 cc's once we cut the tip off. That's not what any of this stuff is.
Right.
That was really the main point. So anyway, back to making things ourselves. I mean, to be clear, we only do it when we have to. But going back to the filter, the F750, it's got this indicator that lets you know when the element is becoming clogged. And of course, we machined this piece here, but there's a little more to it than that. We had to design this indicator. We couldn't just go buy an indicator. It didn't exist. So there's a glass tube there with a, let me see here.
And for those people not familiar with it, what does that even do?
So here's the deal. How do you know when your filter's clogged? When you burn a hole in a piston, that's how you know when your filter's clogged, right?
Yeah, yeah.
Unless you have a fuel pressure sensor on the car, as you should, but not everybody does, and some kind of warning set up in your system that says, hey, fuel pressure is low, you're going to run lean, you're going to blow something up. So the point of this is that if you have this installed in the car in a return style system, if you just hit the key, power up the system, get the pump turned on, it's circulating at full flow, right? Because everything coming out of the pump is just being bypassed by the regulator. So at that point you have full flow, and you can just look here on the indicator and see what the pressure drop is across the filter. So when you get into this hashed area here towards the end, that signifies about 0.7 of a bar, which is going to be, let me see, 7 to 14, let's just say about 10 PSI. You're getting that much pressure drop across the filter element. That means, hey, do you have enough extra fuel pump in the car to be able to support that? So the point is, you literally just key on, go take a look. Oh, okay, everything's fine. This thing starts creeping up, it's time to change the filter. So the issue is that we couldn't just order one of these Delta P indicators, right? We had to make it. So it ended up being quite a design process. I don't know if you can focus on that, but that's the piston in there. And the piston was designed in a very specific manner to reduce friction, because if it has high friction where it sits in the tube, it won't move like it's supposed to, right? You can have pressure build and it'll just stick because of static friction. So if you can see the shape of that, it's got a very sharp edge for sealing and to keep the surface area very small so that static friction is kept to a minimum. And of course, it's loaded with a spring, which is how we define the amount of pressure drop based on based on the pressure differential. So we we had to design this, and we have to build this. These are the glass tubes that make that up. We had to get I don't know my glasses. We had to get a fairly specific tube because the surface finish on the inside mattered. So basically, we have to assemble this whole thing here, put it together into that, to get it in the filter, all because I hate not knowing the condition of my filter, and I wanted to design a filter that had a built-in indicator. And I got the idea from my Dodge Diesel. Have you ever seen those where you just rev it up at full throttle and you look at the pressure drop across the air filter? That's basically what we were trying to do. But
I mean, I think that's another real key point. It seems like a small detail, but most companies would be like, I want that, but that's going to be too hard to pull off, so
Right.
it's getting cut. But
Well,
you guys go the extra mile.
you know, you could say we wasted a lot of time on it, but we've been selling this filter for a lot of years. You know,
Yeah.
I'm sure we made our money back a long time ago on that. But it's just another example of designing and building stuff here. You
Right.
know, just to get it right. It always happens. We have an idea. This is what we want to accomplish, and sometimes we have to do it ourselves.
Mhm.
And then, by the way, I did mention 100% testing on everything. Obviously, every injector, every fuel pump, even the filters, they get leak tested. And then we have to make sure that the indicator is correct as well, right?
Mhm.
So if you look at the manual that comes with it, it says, oh, that's 7/10 of a bar. Well, it better fucking be 7/10 of a bar, right? You don't want to buy a clock with, you know, only 9 numbers on it instead of 12, right?
Right,
So we
right.
got to get it right. So we have to leak test it and then make sure that the delta P indicator is properly calibrated.
And that's done with air, though.
Yeah.
Yeah, right.
Yep.
Okay, is that what
It's
that's
the
for?
Yeah, it's the pressure that matters. We have
Right.
to make sure that the
Sure,
pressure
sure.
is what it should be.
So
Yep.
that, and then this is used in that measure. And then what do you dial in? How do you test the meter?
How do you test?
How do you, or you said you're testing?
Oh, you
this?
literally just get a pressure differential built across it and make sure that it reads what it's
Oh,
supposed to.
okay, got you.
Yep. Yeah. Pretty
Gotcha.
simple process. And then there's a handful of there that are getting ready to get boxed up and shipped. And by the way, there's a lot of stuff that we didn't see being machined when we were down in the machine shop, because obviously, you know, it
Right.
runs certain parts at a time, but we machine all these pieces, the indicator, all that. And then, unfortunately, the one thing that we can't get done to any reasonable level of quality here in Phoenix is anodized. So every single part that you see in here gets shipped off to Utah to get anodized, because as ridiculous as that is, we couldn't find a good anodized company. I mean, we tried California, you know, LA, Phoenix, and they'd do a good job for a while and then they'd fuck a bunch of shit up, or parts would come back and you could see they were banged into one another after anodized. They're like dented and scratched. It's just ridiculous. The only reason we don't do anodizing here is I don't know anything about it. I don't want to deal with the EPA. But the point is,
That's
it's
still
one
a
of the
big
few
step
things
to
that
have
we
to
have
ship
done.
it all out.
It's fucking ridiculous. It's horrible, but it's what we have to do. Otherwise, our product looks like shit. So when somebody pulls this out of the box, they know immediately, oh, these guys aren't fucking around, right? They know that we care about what we're doing. And if it looks like ass, like, well, I know it looks like shit, but it works good, that doesn't fly.
Ben, that's not the type of company you guys are. And that something that simple or small problem has a bigger impact than a lot of companies think. You know, like,
Yeah.
oh, well, there's just a little blim in it, no big deal.
Right.
It's a big deal to a guy you send out 100 and one looks bad, one looks bad. That guy's only buying one. So if his is bad, then you're a shit company.
To him, so if he buys one that's bad, 100% of your product sucks.
Exactly.
Right.
Yeah.
So yeah, that's kind of a problem. And again, it depends on your customer base. I mean, we don't have the product that gets mated to eBay or eBay turbos, right?
Right.
You know, so they're not going to tolerate. They're not going to tolerate bullshit. I mean, look, there's room for all of us in the market. We're at the higher price point. We got to turn out quality stuff.
Yep.
So,
yeah.
Okay. So this is a UTV part, and here's where that was born from. So there's all these UTVs on the market. With anything, if you want to make more power, you almost always need a bigger fuel pump.
Right.
And so the first thing that comes to mind is, well, why don't we just have replacement pumps? You know, we have a relationship with Bosch, obviously, fit replacement pumps into the stock baskets. And when you start looking at doing that, you quickly realize that, oh, this car is easy. Well, this car's not easy. This car's not easy. This one's going to be different than that one and worse than that one. It just turns into a mess. You say, okay, let's build baskets that drop in. Okay, so we build our own basket. How do we handle the fuel level sensor, right?
Mhm.
It turned into a complicated mess that I just didn't want to tackle. It seemed like it was going to be a pain in the ass. Every vehicle was going to be different, maybe less than optimum. There's only so many different pumps available. So we decided to build a surge tank and put a Bosch pump in it, right? And so this is a Bosch brushless pump. By the way, if you look at this, you'll notice, you see there's potting material down inside of there? All right. You see, it's hard to see. Can you see it kind of oozing out around the edges there?
Yeah.
Right? And you see it in here. Now, what that does is seal those electrical contacts from the fuel that's in there.
Okay.
So I don't care if you're running wet methanol or nitromethane or whatever corrosive shit you put in here, the electrical contacts are completely sealed. And so they're not going to be disturbed by the corrosive nature of whatever is in there. And by the way, alcohol fuels, whether it's isobutanol, ethanol, methanol, they're not corrosive until they absorb water. And once they absorb water, they get very corrosive. And you see it when you pull things apart. So none of the electrical contacts here are wetted, right? And this is a brushless pump, so there's no brushes or copper that's exposed to the chemicals. So this is put it in the car and don't worry about it ever again because we've covered everything up. Now, by the way, the rest of it is anodized or stainless steel, right? So we have no issues there. Okay, so anyway, back to what this is all about. We fitted this brushless pump with this brushless pump controller that's built into the bottom of this unit. And you can't really see it, but there's a little LED right there that lights up so you know when the thing's powered up. And this fits into the bottom. The pump gets sandwiched in here like this, right? These pieces like this. These pieces all tucked together and fit inside of this tube with the snap ring top and bottom to hold it all together. And in addition to what we've done there, there's also a replaceable filter element. It's the same element that's in the F750. So in the off-road stuff, there's dirt everywhere all the time. These guys tend to be pretty bad about filtration. So instead of trying to convince them to add a separate filter to the car, which is just a pain in the ass anyway, we just built it all into one. Right. So here's the brushless pump, the controller, and a replaceable filter all in one. And in addition to that, because all these things are tube chassis vehicles, we have application specific fitment for all of them. It doesn't matter if you've got a Pro R, a Pro XP, a KRX, a Talon, Can-Am X3. We've got a bracket system that just bolts to the car with a tube clamp. So basically we sell this as a complete kit with everything, including the fuel lines. Now you can get it without the fuel lines if you want to plumb it yourself, but basically this is something that a guy at home can install on his own. It's just boom, 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 screw shit together, put it in, and now you got a high flow fuel system. Hose kits that go with them, crimped hose kits that are pressure tested and application specific that fit the vehicle. So if you need a fuel system upgrade because you're changing turbos or whatever, you're going to get the kit, the whole box, everything comes, and you just start bolting shit together.
And like, how much power does something like this? What fuels are people running in these usually?
So my favorite is methanol, of course.
All right.
You know that. So the standard version of this, which is what you see here, is good for a pretty solid 400 horsepower on ethanol. That's a lot for a UTV, right? It's about, let me see, that would be 400 on ethanol, 600 on gasoline, and about 280 on methanol. Now your limitation sometimes ends up being not flow, but pressure. This will run up all the way up to 7 bar. Typically we sell it with a 3 bar fuel system, return style. So that means you can run up to 4 bar boost before you run out of this. Let's say you're running methanol and high boost. You're going to make a lot more than 280 horsepower. This is designed to plug into the stock electrical system. So you run wires to the battery for the main power supply for this pump, but it's triggered off of the stock fuel pump. So if you put the vehicle upside down, which these UTV guys do all the time, the system turns off the stock pump. It's going to turn this off at the same time because it's triggered from that. But here's the other thing. This is set up so that if it sees in excess of 18 volts at the inlet, it says, oh, you got a voltage booster. It automatically doubles the pump speed. which approximately doubles the output because it's a positive displacement pump.
Ah, okay.
It doesn't quite double it, but the point is that if you have one of these, you're like, shit, I'm out of fuel. I'm just going extra crazy, like our buddies at LaRue who are making 700-800 horsepower on their UTV.
That's great.
You know, not quite enough. In fact, they've got a BPC in there, but the point is if you need more, literally you can upgrade later just by adding a voltage booster, you know, a JMS or Kenny
Right.
Bell, and or one that we're working on for ourselves right now. And there's no programming or anything. You just hook it up and it says, oh, high voltage. Okay, let me control the speed and double it.
So I have a question in general, but it applies to this. On surge tank setups. You know, I'm a drag racer, so we're not at watt for very long.
Yeah.
So it's absolutely good at that point.
Yep.
How do you account for, like, you know what I mean? Obviously, that's getting supplied by the factory fuel pump.
Yep.
So at some point,
You're going to run out.
you're going to run out.
Exactly. So here's what we've done on that. First of all, the stock pump at this point is just filling this tank, so it doesn't have to build pressure. And you know, with any pump, when it doesn't have to build pressure, it flows a lot more.
Right.
Okay. So the flow rate of the stock pump goes way up when it's just filling this. Now, we've plotted all of that out for all of these vehicles, so we know what those limits are. On some of them, like a Pro XP, for instance, a Polaris Pro XP or a Can-Am X3, basically the supply is infinite unless you add a booster, at which point you should hook the booster up to the stock pump as well.
Okay.
Make sure it stays full. And then on others, we've worked it out where you may find that, like on a Honda Talon, you know, you've got 45 seconds at full throttle. Well, that doesn't sound like much, but 45 seconds at full throttle is a long, long, long time.
Right.
You know, so that's something that needs to be taken into consideration for the end user. You know, what are you doing with it? But
Right.
I was worried about that initially until I started paying attention to what I was doing at the dunes. So, like with my car at Glamis, if I start all the way at the bottom of the hill we call Oldsmobile Hill, and I race all the way up to the top, it seems like I'm in the throttle all day long, right? It's about 18 seconds. So to be full throttle for, you know, twice that amount of time is pretty unlikely, but it's part of the package and information packet that comes with the product.
The one thing you said that I didn't really consider was that, you know, in my mind, I was not thinking it through. Like, oh, well, if the stock fuel pumps support that much power, it
Right.
supports
Why
that
not
much-
just run the injectors?
Yeah, like, you know, but the whole fact that it's filling that up at, you know, no pressure
Yeah.
is what makes up the difference. I didn't
exactly.
consider that part.
Yep.
So I'm glad
Yep.
I asked.
Exactly. And then, of course, this gets mated to, I don't have anything laying out here right now, but it gets mated to our UTV fuel systems. Oh, by the way, I got to show you this because I like to show off what our machinists do. Even this tube clamp we make here.
Wow, really?
Yeah. Yep. And that's made out of stainless so it can get welded. To keep it light, the other half is made out of aluminum. So that's the other half of the tube,
Oh, okay.
or the split collars, as you might call it, for all the different sizes.
So you guys making that entire thing here too? Like, is it getting welded and everything? Or?
Yes. Now, we don't make this bracket.
Right. Okay.
Right.
You get that made,
Right.
but it's
Obviously.
welded here.
Yeah.
Okay.
Yeah. Yep.
You know, you don't do a whole lot of welding here, I wouldn't think.
No, this is
That's probably about it. Right?
this is the first thing here where we have to actually
That's
do
why I
welding.
asked, because
Yeah.
it's a little bit out of your wheelhouse.
But the UTV stuff, there's not a lot sitting here. Most of it's in Texas, but we have the fuel rail and regulator combination. These are the regulator housings here. And as I mentioned when we were having lunch, we convert these cars to a return style system, and the regulator is mounted to the rail. So it's near the injector, so it can do an appropriate job of damping pulsations in the fuel rail.
Okay.
That's probably not worth going into on this video. Just suffice to say that that's what it is. So we sell those complete systems. These two can go together. And on the Yaw Power website, even though these are all Injector Dynamics products, on the Yaw Power website, these are all packaged into complete systems because here we're familiar with them. We've got, you know, a dozen UTVs. And again, Tony doesn't care. Tony doesn't get out of bed for less than like 1,500 horsepower. So a UTV to him is like, well, it's dirty and it only makes 250 horsepower. So I don't give a shit, right? So we're tending to take some of the focus away from those guys because it's just not that meaningful to them. And again, all the Injector Dynamics UTV products will be packaged up on the Yaw Power website or available, you know, through the usual channel. We did a test the other day. I told him to get a video because it'd be a cool video. I said, we're not selling fuel lines that we don't pressure test. Because if you're pissing fuel on an exhaust manifold, that's a problem.
Right.
So we hadn't done it yet. We hadn't built the fixture, but I said we need to decide on a factor of safety. So if somebody's going to run 100 psi, what do we need to test it to? 200, 250, 300. So we've got a little hydraulic pump that we use for pressure testing. Well, anything, filters, you name it. And so Justin was playing around the other day and got all the way up to 1,000 psi before a hose burst. And I said, that'll make a great video, right? So take it out of that protective tube. Wear some safety glasses if you want, but we're going to pump that motherfucker up until it explodes. That's going to make a good video. Anyway, I don't know what our factor of safety is going to be, but if that survived 1,000 psi, what the hell? We'll probably test it to 1,000. If it survives 1,000, I'm not worried about you putting it on your.
And I assume those will be PTFE.
Yes.
Yeah.
Yeah. Which again sucks because they're
Yeah.
you can't
There's
bend them in
pluses
tight
and
radius.
minuses, but
Yeah, but the UTV guys particularly are into alternate fuels. I mean, for one, because it's easier to make power with them, but it's a lot easier to pump fuel out of a drum when you're already dragging your car to the dunes on a trailer. Those guys are more likely to.
And would you agree that even outside of the performance benefit, the safety of the better fuel usually, right?
Safety? Oh, you mean in terms of engine safety?
Engine safety.
Oh, absolutely.
You know what I mean?
Yeah,
It's worth it. Even if you're not power hungry,
Mhm.
if you're going to be beating on it so hard,
Yeah.
having ethanol or
Yeah.
methanol in there is way better.
Especially
Like
something
gasoline.
that didn't come out of a pump. I mean, I could rant for an hour about Pump E85.
Yeah.
And obviously, it's a whole lot better than pump gas for our purposes. Hey, we want boost. We don't want to blow shit up. But in any case, yeah, there are big issues with Pump E85 in terms of cleanliness. There are certain standards that have to be met for gasoline that don't have to be met for E85.
Uh-huh.
Certain antioxidants they don't have to have in there. It's a long list of. It's an inferior fuel, considerably inferior fuel, except from the standpoint of making power with boost or high compression. Then, of course, it's wonderful
Right.
because it has great detonation resistance. So imagine it's like an old college girlfriend who's maybe good at a few things, but
Right.
pretty crazy about some others. Just leave it at that. You know what I mean?
Yeah.
It has some good qualities, but it's garbage. Anyway,
All right. We're over at Paul's personal shop.
call it my garage.
Paul's Garage.
That's garage.
Yeah. That sounds like a YouTube channel to me.
It is.
Yeah.
It's my YouTube channel.
Is it?
Yeah, I've got like a couple dozen really shitty iPhone videos up there.
Really?
Yeah, just total off the cuff shit. I did them like 6 or 7 years ago. The reason I did them was just to practice talking to a camera just off the cuff.
Gotcha.
But there's good stuff in there. It's just super low quality
Right.
crap, but there's good information there.
Well, it seems like you have a couple cars here. We call them cars, side by sides.
Yeah.
Whatever you want to call them. So you use these all for development and things like that?
This one most recently was used just for a bunch of fuel testing. Let me see if you look. It's just a handful of cables in here now because the system is actually in the other car. But this engine is outfitted with cylinder pressure sensors. And the system bolts in here with the logger. Like I said, you'll see it in that other car. And I was using it for testing various fuels and hydrocarbons and things like that. And like we talked about in the podcast, can use this to quantify the fuels. Like, how much energy do I really get out of any particular fuel? How quick does it burn? How smooth does the engine run? Because there's a metric in there that we can use to define that, which basically is a mathematical definition of how much the average cylinder pressure varies between cycles. So this was a fuel development rig mostly.
Is it pretty much a stock setup?
Yeah. Honda Talon. It's a pretty neat car. I mean, unless you don't like off-road shit. Here's what's cool about the side-by-sides, or I like to call them UTVs, but they're all completely different, right? So the market isn't the mess that cars are, where they all have a certain sameness about them. They're all completely different. This one's got a naturally aspirated 4-cylinder. This one's got a naturally aspirated 2-cylinder. Some of them have turbos, some of them don't. Some of them have sequential gearboxes. This one's got a DCT.
Oh, really?
This one's a 6-speed DCT.
Wow. That's
Like I said, the Yamaha's a sequential. This is a CVT, which is, like a snowmobile clutch. So
this one looks like it's decently modified. At least it's got a different seat.
yeah, we built this one to race. It's actually really close to stock, except it's just got enough cage in it to keep from killing somebody. Because this one will do top speed on this is probably, with these tires, close to 100 miles an hour. But something that's common on the track, dirt track, obviously, you might be doing 70 or more, and it's not like doing 70 or more on asphalt where you might spin. These things tumble, and you know, bad shit happens. So the cage is pretty substantial. The seat obviously is a full containment seat to try to keep the driver alive.
Yep.
But the majority of the modification to this is safety related. And then this one is being used for some testing as well. You see the stack of shit in there.
Oh, wow.
That's
Look at all that.
AVL combustion analysis system. It'll do 8 channels of cylinder pressure sensors, or, you know, 8 channels of anything I can do.
How many cylinders is this one?
This is a 4.
4.
It's a 2-liter naturally aspirated 4-cylinder.
So this has 4 channels.
This has, yeah, this has,
one in each.
this is using a sensor in each of the 4 cylinders. You know, so we've got the other 8. I can use
That's
those.
these 4 blue wires here.
Yep, coming out of the valve cover. But you could also be recording intake pressure if you want to look at.
Oh, on the other channels.
Yeah,
Okay.
for instance, if I wanted to look at, you know, intake length tuning, do I need a longer stack, a shorter stack? What happens when I change the taper angle? Shit like that, you can measure that with these sensors. And you can measure that in the exhaust too. Like people talk about tuned lengths of the exhaust, and you want to time the return waves to have like a low pressure area at the exhaust port during the overlap period. You can put sensors in the exhaust port or in the exhaust pipe near the ports to get your header lengths correct and things like that. So a lot of playing around. I mean, a lot of the vehicles here were used initially to develop a fuel system product, and then they turn into, you know, this kind of crazy shit where we dig a lot deeper looking for performance and various things. And obviously you'll notice looking around, like the other part of the tour at the Injector Dynamics facility, everything's fucking spotless. Well, that's a production facility. And if we're going to put out a quality product, repeatable product, everything needs to be neat and clean and organized. And this is me, you know, in my garage wandering around, you know, smoking a fucking cigar at 2 a.m. saying, fuck, let me try this, let me do that. And then when I get done, instead of cleaning up after myself like I force the people that work here to do, I just leave fucking piles of shit everywhere and move on to the next thing.
You keep saying that, but it's not that bad.
This is actually the worst it's ever looked. I thought about this last night. Do I want to let Ken in here with a camera? And I decided
That's way over the top. It looks fine.
If you hadn't been to the other facility, it'd be like, no, you're not bringing a camera over here. But because you've been over there, I'm like, yeah,
we can
fuck
show
it.
off the clean
Who
stuff.
Yeah, who cares? It's a fucking shit
Let's talk
show.
about this thing over here.
Oh, okay. Well, yeah, that's good because it gives an idea of the kind of shit that goes on back here. So, UTV guys know what this is. This is a clutch or a CVT. It's basically like a snowmobile clutch, and you've got the sheaves that change distance from one another, and the gear ratio is continuously variable across the range. So the idea is that if the engine makes peak horsepower at say 8,000 RPM, you stab the throttle, it comes up to 8,000 RPM. And it stays there across the speed range, you know, from basically a dead stop to 80 or 90 miles an hour, however fast it goes.
Right.
That's how snowmobiles work. That's how a lot of UTVs work. So the issue with that, and you found this out when you tried to tune that one turbo car, is that you can work on the engine, but ultimately you got to get it through here. And these have to be tuned or calibrated based on what the engine is doing.
Yep. So what happened was we just went right through the clutch, and
then the RPM just went until it hit the rev limit.
He thought I had he's like, the speed limiter is lower. I'm like, no, that's not the speed limiter.
Yeah, like when you started it, it was probably running at, you know, 8,000 RPM. And then by the time you got done, you were tagging the rev limiter at $9,000, probably
something like that. Yeah.
So you have to tune these. The problem is that it's a typical performance aftermarket problem in tuning these things. You start asking, trying to understand, and you realize that nothing's really optimized. You know, it's kind of fiddle fucked around with to make power on the dyno, but I want it to make power everywhere, meaning at 20 miles an hour, 50 miles an hour, 70 miles an hour. So I've got to dig in a little bit in terms of not just calibrating it, like changing springs and weights, but how does this motherfucker work? So the way that I do this is to make a mathematical model of it. And of course you have to have dimensions to do that. So you guys have all seen it, like a Faro arm or something like that. This is not a Faro, it's a Romer brand.
But
similar. And so you can either scan with it or probe with it. And there are different diameter probes that go on there. And so in this case, like for instance, one of the parameters that I need to know for this clutch is, what are the angle of these sheaves? How would you measure that?
Right.
I mean, you could find a way, but it's not that straightforward. So I don't know if you want to try this or not, but
Sure, let's do it.
if we can always edit it out if it sucks. So this is already open because I was using it just the other night, but it says create features, right? This is the option. So I'm going to say, okay, I want to create a cone. And it says, well, how do you want to do it? You want to create the cone from objects that already exist in the model. Let me get some shit out of the way. Objects that already exist in the model. Do I want to probe? Do I want to scan? You know, a bunch of different ways to do it. So I'm going to probe. And there's some other adjustments I can make in here. Let's see here. Whoops, let me open that up. So it has to know, for instance, this probe is, I think that probe is 5 millimeters, 6 millimeters in diameter. So if I just go and probe it, it's making assumptions that the probed points are the middle of that probe, but of course I got a 3 millimeter offset. So in this case, I tell it I'm not scanning, but probing a cone. I'm either probing the external part or the internal part, like if it was a chamfer, and it will automatically account for that 3 millimeter difference.
Okay.
Here's what's cool about it though, for taking measurements. It allows you to be a fucking slob and it just pieces it all together for you. So I'm gonna try to do this with a cigar in my hand. Basically, you just come over here and you just grab a point, you pull the trigger, beep, another point, another point. You start grabbing points on the cone. Get some back here. Reach over here. If you weren't there, I would probably walk around and I wouldn't have a cigar in my hand, but right? So this is an interesting stat. What this says is that so far the standard deviation between what it assumes is a cone, a perfect cone, and the actual measured data points are basically 2.1 thousandths of an inch. So what we're saying is we have a pretty damn good fit to an actual cone. So then I press the button here to say that I'm done. And of course you can't see it because it just showed up on top of the other one because I'd already scanned this. But there's my cone. And then it gives me the dimensions. There's the included angle, you know, the length, the taper angles, dimensions related to where it fits in the coordinate system. And it does, you know, in this case, it does a cone, which is great, but it does a lot of other neat things. So let's see here. Let me just kill this. Let me kill this one too. Maybe I want to do, I'll do another one. Maybe I want to do like a sphere. And here's what makes this thing really cool. Let's say I want to do a sphere. Same thing, I just grab a bunch of points and it takes those points and says, oh, this must be points on a sphere, and it calculates the diameter, the center of the sphere and all of that. But let's say I'm doing suspension work and I need to have measurements on all the pivot points. So one of those pivot points is the center of the ball and the ball joint. So you can just peel the fucking boot back and grab what points you can get to on top of what part of that ball is exposed, and it says, oh, this is a ball this big around, and oh, by the way, here's the diameter, here's the center of the ball relative to the coordinate system. Yeah, and so you can reverse engineer everything.
Oh, wow.
Basically, that's the whole point. Or you can scan, you know, you flip the switch, and everybody's seen that shit before.
Right,
I could scan you or your fucking tennis shoe or something like that, and it brings those shapes
Make
in.
a model.
But I tend to use it a lot in this mode where I'm grabbing geometry, you know. And by the way, I use it on the suspension too. So if I want to know the motion ratio of these shocks, what I mean by motion ratio is how much does the shock move for every inch that I move the wheel, right? So I take the wheel off, and this one's probably got, oh, this one's got it already. See that dimple in the end of the bolt? So I sucked the bolt in the lathe, and I used a center drill to put that dimple in there. And you have the same thing here on the axle, because that's part of the machining process. And then we've got another dimple up on top. So I come over here with the probe. I have the suspension at full droop, and I put that probe in that dimple. I pull the button. That's my vertical position of the wheel. Actually, let me back up. The first thing I do is I go beep, 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 beep at several points on the floor. And in making a plane, it says, oh, this is the floor.
Right.
Okay. Then I do this, and it says, oh, the wheel at this point is, say, 4 inches off the floor. And then it takes these 2 points, same thing, I put it in there, beep, put it up here, beep, and it says, oh, the damper is this long.
Right.
And then I move it up by any amount. It doesn't have to be exact. I'll have a jack under it. I'll move it up. Let's just say an inch. Beep. Okay, the wheel just came up an inch. Then we go to this, and now we realize that the shock got shorter by maybe 7/10 of an inch.
Right.
So we do that throughout the range. And then to throw some math at it, just to piss people off, we take the derivative of that, and we end up with the motion ratio of the suspension, but not an average, the motion ratio at every point. And so that's critical because that determines the force ratio as well. Like, if moving the wheel up 5 inches only moves the spring 4 inches, or half that, let's just say 2.5 inches, then 1,000-pound spring doesn't correlate with 1,000 pounds per inch at the tire. Right?
Gotcha.
That's why the motion ratio is critical.
Okay.
And critical for velocities as well, because you put a shock in the dyno, and we say at 20 inches per second, the shock generates this much force. Well, what's the actual velocity of the wheel?
Right.
Right? So anyway, that tool, it'll sit and collect dust for months at a time. But then when I need it, oh, fuck.
It's priceless.
Oh, yeah.
Yeah.
It makes it easy to measure things. You know, the other thing you can do is you can scan something, and then you can bring it into the software and say, okay, grab this flat surface, and it will grab it and dimension it. Oh, let's grab this radius, and it'll do the same thing from a scan.
Okay.
So you can use it for oddball shapes, and then turn what seems like a bunch of oddball shapes into proper geometric shapes. So it's a hugely powerful tool. I use it for a ton of shit.
Very
Yeah.
cool.
Yeah.
Let's talk about what's in that room over there. I'm very interested in that.
I don't know what
I know
you're really intrigued by this thing, aren't you?
Yeah, I am.
Okay, so the short story.
This whole room I am.
Oh,
not
well,
just
yeah.
The machine.
So
but the
look,
machine.
does your kitchen really not look like this?
My name's not Walter White.
Yeah, no shit. Okay, so look, just to be clear, there's some silverware and some cups over there, so it does occasionally get used as a kitchen. Okay, but anyway, obviously that's a bunch of chemicals, and I'm not fucking cooking meth back here. Right? I'd have a much nicer car if I was cooking meth. We're batching custom fuels. We could talk later about why that is, but the point is that when we order a chemical from anywhere, that 5-gallon bucket right there says pentanes. It's normal heptane, N-heptane. No, I'm sorry. This is
ISO.
It's isopentane.
Isopentane.
It's not pure isopentane, just like this isn't pure cyclopentane. It's mostly isopentane, right? It may be 97%, 98%, whatever the case may be. So we can take any liquid, and we can't do it right now because we don't have any helium, but we can take any liquid and we dump it into this machine, and a whole bunch of magic shit goes on inside. And then ultimately what we get is a report that says this liquid is, 97% isopentane, 1.3% this, 0.4% that. And it breaks it all down and lets us know what's in it. And like you said, what's that stupid fucking TV show with the hot bitches on it? Wait, that's every TV show. Yeah. CSI or some shit like that. Yeah.
Well, I was talking about Forensic Files.
There you go. Yeah. And they're always using,
Yeah.
And it's probably, an Agilent piece, same thing.
And yeah, because you're using it for these chemicals, but it'll work with any liquid that's.
Yeah, because it's got a database that recognize. I mean, look, you could spit in it.
Yeah.
And do it. And the database that exists is big enough that it would probably recognize a lot of those things. It'd be a lot of proteins and carbohydrates and fats and things like that in there. I'm not using it for that because that's shit about that.
Yeah, that's cool.
But yeah, it's kind of a little magic tool.
What if you put your blood in there? Well,
yeah. Now the thing about it though is your blood has some solids in it, and I don't know what would happen to those solids, because what happens is you put it in, it heats it up. You have to set the temperature to heat the liquid up above its boiling point so it turns into a vapor. Turns it into a vapor, and then it uses a carrier gas, in this case helium, to pump it through a long copper coil, really tiny inside diameter coil. That coil is coated with a catalyst, and to be clear, I can't explain exactly how it does what it does, right? It's just some piece of fucking magic.
Right.
Anyway, the point is that if you have solids in there, they're not going to evaporate and move through correctly. So
Gotcha.
I don't know what would happen. I'm sure it would just fuck it up and clog shit up.
Yeah.
Then I'd be calling them, I got blood in here. But yeah.
Well, you were talking about, vaporizing it.
Yeah.
Let's go. You want to go look at that the other machine?
Yeah.
You were talking you
Yeah.
do distillation.
The
curves on?
still.
The still,
I
yeah.
call it the still, like if we're making whiskey. And like I said before, we can actually run some shit through here if you want.
Yeah.
I've got to replace, by the way, this beaker broke the other day. I have to replace it. And I think it's funny, by the way, because it does look like a crack. Well, actually, because it's broken, that's not so clear. Let me show you. Does that look like something you should have in your garage?
No.
All right, so here's
My
how.
mom found that, she would have did an intervention.
Yeah, exactly. So this stem broke off. I mean, it's glassware and it gets beat around, and every year or so some piece breaks and you have to replace it. But the short story is this, and again, we can run it later on. If you let me set this down. If you zoom in, you can see that this is a thermometer, and so you fill that with liquid 100 milliliters, and underneath this thing is a heating element. I don't know if you can see that or
Yep,
not.
I can see it through the way.
Oh, okay. Yeah, there's a heating element. And essentially, it heats the shit up and boils it. And this thermometer tells you the temperature of the vapor that's up here. And if you use this one that doesn't have the stem broken off, this stem goes down into this passage with a silicone cork that seals it up. This tube is cooled, it's chilled, there's a little air conditioner in here. So it then condenses the liquid, runs down the tube, ends up in your graduated cylinder that goes in here. I left it in the kitchen. I should have grabbed it. And it's graduated so you can read it, but this little device here, I don't know how it works, but it senses the liquid level in there. And so what it spits out ultimately is a graph of percent of the liquid that's evaporated by temperature. So let me change to a different screen. Trying to think of the best way to display this. And then I can try to explain why it's important. I think I'm in compare mode. Let me just go back to, got one here that's jokingly called O'Doul's because it doesn't have any alcohol in it. Okay, so what you get is a couple things. One is a graphic version and the other is a table. And so basically what this says is the initial boiling point, the point where we get the first drop of liquid in here happens at 104 degrees Fahrenheit.
Okay.
Right. And then we go on up through the range. And to get 95% of it to evaporate, we had to get all the way up to 143 degrees Fahrenheit. Now, this is, I'm not going to tell you exactly what that is. It's got some weird shit in it, but let me move on to something like pump gas. Let's see here. There we go. Some pump gas from Costco. And now we see that the initial boiling point is 113 degrees. We work up through the range. We have to get that up to 390 degrees Fahrenheit to get 95% of it to boil off. So let me get this out of the way. Here's why this is important. Let me show you the graphic. Here's the same thing graphically. The brown line there is the rate of evaporation. It's how, I'm sorry, yeah, it's the rate of evaporation, how quickly the stuff is boiling up out of there. This is the temperature of the heater below that was required to attempt to meet that rate of evaporation, which is between 4 and 5. And then this is the actual curve. So this is volume. And basically what we see is to get 50% of this to boil off, we have to be at, just a little over 200 degrees. Okay, so here's why this is important. First is cold starts. If I were to put, let me just take, toluene is a molecule that's common in pump gas. If I were to put toluene in there, this just does nothing, and then all of a sudden it jumps up to 230 degrees and just holds steady all the way across. And what that tells us basically is that we have to have a lot of fucking temperature to vaporize that shit. And if you can't vaporize it, it can't burn. And so like when you put E98 in a car and you're like crank, 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 well, the problem is if I had used ethanol as an example instead of toluene, you would see that it jumps up to 173 or 106. I can't remember which degrees, and it just holds steady all the way across. You have to get the shit hot to get a substantial amount of vapor off of it. And that's why it's tough to get it to cold start. So the way you get a fuel to cold start is you put compounds in there that boil at a lower temperature.
Ah, okay.
Right.
To help it vaporize.
Like, what's up here? There's probably some isopentane. All the way there in the back is some isopentane. Isopentane boils at about 80 some degrees. If we were to go outside in hot weather right now, if I were to spin the cap off, pour some in the cap and just fling it up in the air,
Mhm.
would never make it to the ground. It'll be vapor before it would ever get there.
Oh.
So isopentane is a real common volatility improver in race gas to make cold starts work, and it can help throttle response and things like that. And then on the upper end, going back to pump gas, this stuff is all very tightly controlled by the government. And one of the things we see here is that to get 95% of pump gas to boil off, we had to hit almost 400 degrees Fahrenheit. And so if those numbers are on the high side, and that is, pump gas it's got some pretty high numbers there. What that means is that that fuel doesn't vaporize until real high temperatures, and it can be a little hard to burn that stuff off. And if you don't burn it off, it makes its way past the rings into the oil. Right. So if you have fuel that has very high numbers up on the top end, you run into issues there. So that's regulated by the government. The volatility down low is regulated because if the fuel is too volatile, it tends to boil off on a hot day and end up in the atmosphere. If it's not volatile enough, you have bad cold starts, and then you have a lot of hydrocarbon emissions during that period. So it's critical for pump gas to meet specs, and then it's also critical for race gas to dial it in to get the response that you want. So,
Awesome.
yeah, anyway, that's just one of the tools. This is getting moved in there next to the GC, by the way, out of the way here, since it's sitting next to my fucking shock bench, right? I mean, and that's just scattered after almost 2 weeks straight of working on a set of shocks.
Yeah. Well,
That's some goofy shit, huh?
yeah. Well, speaking of shocks,
Yeah. So this particular shock dyno, even though it's old, is pretty advanced. And I use it for a lot more than just shocks. It's got those fixtures in there right now because I was testing clutch springs. So I can use it to rate springs, and any kind of spring. I've used it to rate valve springs before.
Wow.
Just about anything. You can do a lot of shit with it. And you've seen the video where I had a tire on here.
Yep.
Put this on the bottom. We can test the spring rate of a tire, which is critical because the tire is a spring.
Mm-hmm.
And a big part of suspension tuning is working with the fact that tire is a spring. You can also run that tire through a whole frequency range and get a feel for the amount of damping that's inherent in the tire. It's a tool you can do a lot of shit with if you are creative and do it. And that web YouTube page that I mentioned is mostly this shit.
Yeah. And this was some of the stuff that you also posted on Facebook back in the day was on the shock dyno and all that. So
Yeah.
definitely check out. We'll put a link to those videos down in the description if you guys want to check that out.
There is some really good technical information there for you guys who are just total fucking geeks.
Yeah. Well, and that's the point. If the content's good, it doesn't have to be the best production.
Yeah. And I misspeak and fuck things up, and it's not the kind of YouTube page that's going to make anybody any money.
Yep. And then you've got a bunch of other cars over here. You were saying that this was the newer car that really hasn't run yet, right?
Well,
This
is
run, but in its newest form.
This is a Kawasaki KRX that we were building for short course racing, and the state of short course racing in the U.S. has changed a lot. The Lucas Oil Series, which is the one that we talked about in the podcast, fell apart during COVID, and the things that have come up to replace it since then have not been anything that I'm thrilled with, right? So we're building this car, and then the whole thing just kind of falls apart. The people we want to race against aren't racing anymore, and it's so much work to build and field a good race car. I only want to race people that make me nervous. What I mean by that is when I get to the track, I'd be like, man,
You want to have
what
fun.
are those motherfuckers got in store? You said fun?
Well, that's what you consider fun. You're not, if you know you're going to show up and just dominate, it's not fun.
It's not fun for me.
Yeah.
And I feel like a dick.
Yeah.
Yeah. I want people that make us nervous because that makes you work.
Right.
And then you do cool shit.
Right.
So that stuff's kind of falling apart. And I'm not saying there's not good racing out there. It's just that
What do you think caused it? Just people moving on to different things?
well, I mean, would you agree that most racing organizations don't make a lot of sense financially or business wise?
Yeah. Yeah.
So I don't know, it just kind of fell apart. I don't know why. I mean, if I did, actually, the truth is if I did know why, I would start something up myself and do it. But I don't know. But when we raced in the Lucas Oil Series, we didn't recognize it at the time. But the two guys that we were battling with ended up being, in my opinion, two of the best short course racers in the country. You know, one of them is racing for Polaris now in the desert, and he's just fucking killing it out there because this kid is he's just an insane talent. And then the other one was a kid also, a kid named Miles Cheek. He hasn't been doing a lot of racing lately, but he showed up in like stadium super trucks and he won a race there. You don't win in stadium super trucks unless you're a bad motherfucker, because you're racing against Robbie Gordon and Matty Brabham, and those things are really fucking hard to drive.
Yeah.
So we were racing the best of the best, in my opinion, and they're not available to us anymore, so to speak. You know what I mean?
Mm-hmm.
So, and I don't want to make it sound like I'm talking shit about the lower level guys, but that was serious high level stuff. And when you compete against those guys, you do your best work. So I'm not going to put this much fucking work into something unless it almost kills me to win.
Right.
Because that's that feeling of accomplishment at the end of the season.
Right. If it comes too easy, it's never as much.
And I don't want to say easy. It's always hard. It's just that it has to be so hard that it makes me do things that I didn't think I could do.
Mm-hmm.
Like, oh, I figured out something on these shocks that's so fucking cool. I did this, or the driver.
Yeah.
You know, oh my God, I figured out this. That's what we want from it. And if I can't have that, I'm not going to put this much work into it because it's fucking expensive. It's time consuming. So this car's 80% of the way done, and it's fucking parked, and it kind of makes me sad, but I'm focused on business right now instead. So
yeah,
it is what it is. We'll get back to it eventually.
I just saw looks like you've got your surge tank set up here. Is this jig set up to weld it or what?
Oh, that was a welding fixture. Yeah.
Yep.
Yeah. I believe that clamp is for a Can-Am X3. You know, as we were going through that process, we had a lot of machine work to do, but we also had to build some fixtures for, you know, production of the bracketry and things like that. So in this shop is where all that shit happens. Right. I mean, obviously this isn't the nicely organized shop. This is the, hey, let's figure some shit out shop.
So are you doing, this is where you do the production ones?
Well, we have several of these out there, but these aren't in full production yet.
Right.
But yeah, full production.
No, I mean, this jig though, like you're not.
I don't expect full production to happen here, although that jig will be very, very similar to that. I mean, you literally just need a way to hold it in place while you weld it.
Yeah.
You know, but it has to be dimensionally correct. So whether or not it may happen in this facility for a little while, but I mean, it's too messy here to try to do production. There's too much shit in this shop to try to do production.
Yeah. Looks like you got a flow bench over here.
Yeah. Super sucker.
Super sucker. What are you testing here? Some stacks or something?
Yeah. I was actually working on the cylinder head for the Kawasaki. And then, you just 3D print whatever fixtures you need to get shit done, including this piece to adjust the valves.
Oh, wow.
That was actually a 3D printed piece that ended up being a pretty helpful tool.
Yeah, that's awesome.
Yeah, to get it done. I was trying to get some better airflow through that cylinder head because we got to make some power.
Yeah.
Especially since, by the way, the Kawasaki is considered to be the lower power of all the UTVs. Mm-hmm. And it has more to do with the chassis than it does the engine, but still I had to work hard to make power because most of my cars end up being heavy because I don't want a dead driver. Mm-hmm. And safety in off-road, at least in the UTVs, is, in my opinion, not nearly as good as it should be. Mm-hmm. But I don't want to fucking kill anybody. So my car's littered with fucking tubes, and everybody else is like, well, fuck that. I'm just going to put enough tubes in there to keep the tech guys from crawling up my ass.
Right.
So we're racing a heavy car. And the Kawasaki is a heavy car to begin with. Mm-hmm. So it's a heavy car. And then I made it heavier. And now I've got an engine that, doesn't even compare to the YXZ engine in terms of power potential. So I was digging pretty fucking deep.
Very cool.
Yeah.
What's this unit here?
That is for measuring camshafts. That measures camshaft profiles. And that's a quarter midget cam that's in there right now from Ian's little race car. It's only got 2 lobes, 1 intake, 1 exhaust. Basically, you put the cam in there, and of course, you get lift and duration and lobe centers and things like that. But you also get velocity, acceleration, jerk, all the derivatives. And so if you were doing camshaft design, and by the way, we had custom cams cut for this, and we're like, this is the acceleration limit. This is where we're going with this. We want this lift, this duration, and specified an acceleration limit, right? Okay. Which is actually determined interestingly, by the diameter of the bucket. But in any case, if you want to get serious about camshafts, you either have to have somebody you really trust, or you have to check everything yourself.
Yeah.
And it's surprising how often you check things, they're not quite what they're supposed to be. Yeah, it happens.
So I've heard of a cam doctor. This is obviously is this similar or?
It's basically a cam doctor, just a higher level, higher quality cam
Yeah.
doctor. And the reason I say higher level, higher quality is that there are some real issues here with friction and potential measurement errors. Like, this indicator, that's the brand you want to use if you want really accurate measurements. But the other thing is that this is often based on curve fits, and so the mathematics have to be good. So it's just it's a pretty high quality piece. It's more expensive than I wish it was, but if you're going to do it, you may as well do it.
Yeah, absolutely.
And things like this get used for other projects that I won't detail. Sometimes it's for our own racing. Sometimes we're doing stuff for other people. That's the old YXZ that you may have seen video of. There's a last race at Texplex in the Outlaw Series where we'd had some struggles, and basically we got the car dialed in, and Robert, the driver, basically said, fuck you, this is my last time here, and I'm going to make sure you remember me. It's a pretty epic drive, and it's all on film. Well, about half the race is on film from a drone, and this is the car from that video. This is the 10,000 RPM YXZ engine.
Very cool. What happened to the car that he won the championship in?
This is funny because we were over in Building 5 the other day. That car was over in Building 5. I didn't look to see if it was still there. It may have gotten moved to Building 6. We kept that car. I didn't want to get rid of it. Besides, that motherfucker was used up. So this is a cool story. We get to the final race, and it's in Chandler. Good. That's kind of like hometown for me. And Robert liked that track. So the thing about Robert Stout, the driver, is that he's one of those guys. He's like Jackie Ickx. He goes out and he goes fast as shit, and he does it over and over and over again. He doesn't make mistakes. He's that kind of a driver. He never says it, but I think he prides himself on not making mistakes. The problem is that in off-road, every fucking lap is full of mistakes because the track's never the same twice. Everything's rutted up. You don't have any traction. It's almost like bare knuckle fighting rather than racing,
Right.
But he's just one of those guys, really super precise from doing open wheel cars and shit like that. So he goes out and practice. And when the Lucas Oil Series was running, they always had this big lighted billboard. And during practice, they would show the times and the position of the drivers. So Robert comes around and he looks up and he's like, holy fuck, I got 7/10 on the field and I got 2 laps left and I'm just getting warmed up. I'm going to lay down a burner. It was the last race. We were pretty sure we were going to win the championship. And he's like, I'm fucking going for it. Well, he goes into the right-hander, and there's video out there of this. And the car, slides into the right-hander, and then, boom, it catches a rut, and it goes for a fucking tumble, and not just a roll, but that roll turns into an endo, where at one point, you have to point out to people when you show them the picture of the car in the air, upside down, you're like, yeah, that's a right-hand corner, because the car's facing the wrong fucking direction, right? Okay, so this is what makes the story cool. We get it back into the pits. Motherfucker, now we got to qualify. I'm like, we just lost the championship. We don't even have a fucking car. So somehow Chris and Asa get it back together. We get it out there just in time. Robert's fucked. He bashed his head. You see the video. It was fucking violent. Somehow we get it back together. It's still kind of fucked up. We get it together, put him out there for qualifying. He makes it out just in time for qualifying, like 5 seconds before or maybe 10. Stories get better over time. And he's fucked. I mean, he's not even really speaking, or he's just, he bashed his head pretty bad. Motherfucker went out there and put the car on the pole. We're like, what the fuck was that? And when I ask him about it now, he's like, I don't really remember that. And then, so the car's fucked up. I don't know how he put it on the pole. He goes out for the race. We only had to finish 4th. He stayed out of trouble. He finished 3rd, won the championship. And that car meant so much to me, even though it was all used up, fucked up, beat up, that I just kept it.
Very cool.
And by the way, the car was so fucked up that the wheelbase on one side was about 2 1/4 inches shorter than on the other side.
Oh,
That's how bad it got fucked. And somehow he put it on the pole. I have no idea. He doesn't have any idea how he did it. And that was our spare car for 2019 that we built that never got raced, that's literally been used for nothing but stealing parts off of for spares. It sits here and collects dust. It has for years. We're going to put this up for sale. It's essentially a brand new car that never got raced. Wild, huh?
what did he? I assume these all run on like spec fuel.
Okay, so this did. Yeah, we had to run this on, we had a choice of either VP UTV 96 or Sunoco SS 100. This one in the Outlaw series, we didn't have a fuel rule. So this one we were running on methanol with some stuff to improve volatility, some stuff to improve detonation resistance, and about 20% nitro.
Right.
Made it's a 1 liter engine. It made 176 horsepower measured at the hubs. It was a pretty badass car. Handled really well too. This is a good car, really good car. And it's been sitting partly because I didn't want to race a Yamaha. I wanted to do something new because I felt that after winning the most prestigious, short course UTV championship that there was to win, I thought they should have treated us a little better than they did. They didn't fuck us. They didn't really help us very much. So I'm like, well, fuck you. I'm going to build a Kawasaki instead. And by the way, Kawasaki builds an absolutely phenomenal car. And I got more help from Kawasaki and more care and more give a shit from those guys for a car that I never even raced
Right.
than I did with Yamaha. And we won a championship for them. So it's like, all right, race something else. And so now it's parked.
So how much of, on this is custom? All of it, or like the
So everything from here down, well, that's not even true. Okay. All this stuff down here is stock. All this stuff is not.
Yeah.
How's that?
on the roll cage? What about like are all the control arms, all that stuff? Is that,
No, none of those control arms are stock.
yeah, I didn't think so. They look
No, not all. The car's about, I don't remember exactly. It's somewhere in the neighborhood of 8 to 10 inches wider than stock.
okay.
The intake is, well, it says Weller Racing on it. That's a local company that does YXZ stuff. It's just their lid. The intake is the runners are all custom. The headers are custom. If you look, you notice there's a lambda sensor in each pipe for individual cylinder tuning. This head has plugs in it right now, but this also had cylinder pressure sensors in it, so I could, really get it dialed in. Yeah, there's not a lot stock on this car because it was the Outlaw series.
Right.
Even the whole anti-roll bar setup back there is not stock. This is all stuff that we built in our machine shop, except the arms. We didn't build those. We bought those, but we built all of that stuff. Anyway, so we went from being real serious to about racing to fuck it, park it. Let's be real serious about business because of a shitty economy and not a place to race where we really want to race.
Are these just all different rates?
All different rate bars. Yeah, if you look, there's different thicknesses.
Yep.
The outside diameter is the same, but you see this one.
see
See this one's turned down. Wall thicknesses are different, and then we have adjustment here as well. So we could use it to dial in the oversteer, understeer characteristics of the car. And this car doesn't have a bar, anti-roll bar on the front. So yeah, there's a lot of custom shit on this car.
Very cool. I'd like to go for a ride in one of these at some point.
I'll take you for riding the Pro R. We'll see if we can tip it over and give you a concussion. Oh, I have to tell you, I'll tell you who after you shut off the camera, but the Can-Am's sitting outside. You'll notice the top is bashed in and the light bar is kind of fucked up. So I had a business associate here and I took him for a ride there in the back because there's another 1.5 acres back there behind the fence. And I was showing him how in the dirt, you don't just get to steer it, you kind of gotta, kick it in and get it to rotate and get on the throttle and get it back out. And that car being mostly stock, it was hard to get it to rotate. Anyway, so he went out and got after it and I hear a thump, crash, and I go out there and I've got a picture of it. The car's sitting upside down and I'm laughing like, oh man, I'll tell you who it was later. But anyway, yeah, so you got to be careful in them. I mean, they have a high center of gravity compared to a regular automobile. So It's not like you're going to slide off the road.
Right.
You might go for a tumble. And sometimes they just roll over. Sometimes they roll a couple times. Sometimes they go over and they'll land on a corner and that'll turn into an endo. And sometimes it's really fucking
nasty.
violent. His crash in the old race car was fucking nasty. It was one of those that just jerks you around.
I think I remember
it broke the
seeing
fucking
that.
seat. I mean,
Yeah.
It was bad.
Yeah.
Yeah. So after getting a
And to
beating,
qualify #1 in it after that is crazy.
it is. It's the most memorable thing in racing for me out of all these years is that. And he doesn't really remember it.
You can watch it on video.
Yep. This is another Kawasaki KRX. This is being used for development right now for the coil kit, the ignition upgrade.
Okay.
This is actually a custom piece.
Those are the bolts that we.
Oh yeah, those are
Those
yes.
are the bolts that we looked at earlier. So that'll be
Yeah,
good.
and that's part of the coil bracket right there. That's an initial prototype that's going to change.
Okay.
But yeah, because we were doing some vibration analysis, take a look. That thing on the side is an accelerometer.
Oh, okay.
We're measuring the acceleration of the coils because there's a spec on that, which is maximum of 25 Gs. Any more than that, and basically you say to Bosch, hey, I bought, 1,000 coils from you and they all failed. They're like, well, you exceeded the acceleration threshold, so go fuck yourself.
It's near that. It's anywhere. It's even in the ballpark. Of that?
Depending on what we do there. Now, I heard a story from, I'll just say, one of the UTV manufacturers that explained to me why they didn't use coil on plug on one of their models. And they said because they were measuring acceleration levels in the neighborhood of 100 Gs and the coils wouldn't live. So they have a remote mounted coil.
Wow.
It's an engine similar to this.
That's,
We're taking a slightly different approach because I hate spark plug wires.
yeah, that's crazy. That
Yeah.
there's that
So
much
that's what that
on
accelerometer's on there for. And if you look, there's a Bosch. Bosch, for a while, decided to try to do some inexpensive electronics, which to me was a really bad idea. I'm like, you're Bosch Motorsport. Don't try to play that game. But anyway, it's got this piece in here, which is a pretty inexpensive dash logger. And it'll log at 1 kilohertz. So it'll log at a pretty high frequency. So we're using this to log the accelerometer.
Okay.
To see what's going on there.
Very cool.
Anyway, everything in here is being used for development of something,
Want to walk down this wall over here and look at some of the machinery you have here.
Oh yeah. You got to move all the shit out of the way.
Yeah, but that's my
You're going to need a fucking tetanus shot by the time you leave here.
I'm going to need a bed for like a week after this.
Yeah. This is just usual fabrication shit. Like most guys that are doing things with cars, I started out building shit. And I have to have a lathe. I have to have a mill. By the way, this is an interesting piece. This is a mill mount crank balancer. And the reason I want to mention it, I got to remember the name of this company. Right there. The reason I want to mention it is that I'm constantly pissed off when I buy products because they suck. Clearly somebody didn't give a fuck about the quality of the software or whatever it may be. And I bought this, it was fairly inexpensive. And I know enough about balancing that I was able to do a number of tests and make sure it's accurate. But the most important thing is that everything about this balancer was exactly as advertised, and the software is completely bug-free and easy to use. So much so that I called the company and said, I need to talk to the owner. Oh, he's busy right now. No, I need to talk to the owner. Finally, I said, look, I'm so impressed with this machine. I got to talk to the guy to tell him that I'm happy about it. So please do me a favor.
Yep.
Turner Technology, it's a mill mount balancer. So when I'm not using it, we just put it back in its Pelican case and we put it away.
Very, very cool.
Really cool company. Really cool company.
It's cool for you to give them props like that because, like you said, the reason you are is because it's unfortunately rare for that to happen.
I mean, if you have an engine building shop, you're going to buy a Heinz, full-size balancer because you're using it all day long.
Right.
But here you buy this, and then it works just like the others. You got basically your drill press here to modify the counterbalances. It's a great piece.
Very cool.
Really, really good stuff.
Got some other fab. What's the Piranha here?
Yeah. Bandsaw. This is something I use all the time for shocks, this little surface grinder, because the surprisingly inside of a lot of shocks, the pistons and the backup clamp washers often are not very flat. And so I'll build 2 shocks the same and put them on the dyno. I'm like, well, it would be nice if they were the same, and they're not. And then I can come in and flatten the pistons and put them back together, and then they're the same. Or I've had situations where the piston in the remote reservoir, let's just say the piston in the remote reservoir is not functioning correctly, and I'll work on the shock and I've got some cavitation issues. And what happens is there's cavitation issues because there's not enough pressure in the chamber because the fucking piston in there is not flat and it's not sealing and it's not making enough force. And literally come over here and grind the piston flat and put the thing back together and it stops cavitating. Shit like that. So that's a necessity. And that's about all it ever gets used for is grinding shock parts. But,
the Piranha thing, I think I saw this before at PRI or something. This is like a
yes.
Does a bunch of different things.
Does a bunch of shit. It shears, it really thick stuff. It shears, it punches, it breaks, all that stuff, and thick stuff. So this doesn't get used very often. When it does, if you want to fuck with a piece of 1/4-inch plate, for building brackets, things like that, it's a pretty nice tool to have. And, bandsaw, sanders, grinders,
normal
cheap
stuff. But,
cheap shitty drill press.
This is your house. or your,
basically, yeah.
basically like it's not. This is
It's my
what you
garage.
have here is a top level shop. So when you say basics, it's like most people would love to have this as their actual business type of shop here. And this is just your R&D kind of slash fun space.
Yeah, like I said to you before yesterday, the shop tour you did over there, that should be my dream, right? I've got this gorgeous facility, super organized, people doing great quality work, and it is really cool, and I'm proud of it. But this was my personal dream. I want to have all this shit in my garage so that at 3 a.m. I go, I got an idea. I got to go build that and test it. I can come back here and build it and test it because there's everything. Where's the fucking tubing bender? There's a tubing bender, roll cage work, bead roller, sheet metal brake, shear, I don't know, cold cut saw. I mean, it's pretty much all here. There's not much that I can't build.
So when you're adding to these cages, you're doing that, or
No, typically, if I need to add to one or modify something, we'll do it here. But when it comes to building one, let's go back over and look at the Kawasaki. There's another company I want to talk about. There's a company in town called Lone Star Racing, and there are some bad motherfuckers. And not only are they bad motherfuckers, they're real patient. The reason I say they're real patient, well, let me get to the bad motherfucker part first. If you look at the quality of construction on this cage, this is just absolutely beautiful work everywhere, everything about it. Here's the patient part. I showed up there at their shop every morning at 6 a.m. while this was being built. This is horrible. I'm surprised they let me do this, or they didn't kill me. And I specified where every fucking tube on the car goes. The reason is that fabricators are not structural engineers. They often put tubes in places they shouldn't be putting them. It's like, no, don't do that. That's not, you've disturbed the load path, or something is loaded in bending instead of compression or tension. If you look at this car, particularly around the driver's head, we have in any race car with a cage, you got 4 points above the driver's head. He's sitting underneath a rectangle. Each of these 4 points is the intersection of at least 3 tubes, right? And so what we end up with is a very rigid structure around the driver. But then the other thing is that a lot of off-road cars, like let's just say the green one over there, you see the tube at the base of the windshield?
Yeah.
That was a requirement for the rules. It's a fucking stupid tube because you've got the bars that come down from the top, but they don't go anywhere. They go right to the middle of a fucking tube. It's retarded. But those were the rules, okay? So on this car, these come down and they tie into the front shock mounts. That's where all the fucking loads are fed into the chassis. And they feed in right there. So this serves the purpose of protecting the driver, transmitting load from the highest loaded point in the vehicle up to, the spine that runs through and all the way to the back. So this handles strength in terms of protecting the driver and chassis rigidity. Because if the chassis is flexing, then the dampers aren't really doing their job correctly, and everything just goes to shit. So everything here, if you look, everything that we've added is a triangle. There's not a fucking rectangle in this car. Everything is a triangle because that's what distributes load the most accurately. Because if loads all come into points of a triangle, everything is either a tension or compression load. So think about, you've picked up a 20-foot stick of roll cage tubing and you carry it and it's going like this.
Yeah.
Well, it's because it's loaded and bending and it's flexible. You ever try stretching one or compressing it? It doesn't happen.
Right.
So if everything is a triangle and the loads are fed in at those tips, nothing is loaded in bending. It's all loaded in purely compression or tension.
Right.
So this entire cage is laid out that way. And by the way, that bar there is, if these cars jump and they jump high, if somebody lands on top of this car, I don't want him making his way in. And even though we have 3 points there, they're at a shallow angle, and I wanted to make sure that couldn't cave in. So we have this final tube that runs all the way down here to this corner so that point can't cave in on the driver.
And fold in this way.
And fold in on the driver.
Yeah.
And even the door bars, everything's triangulated. There are no bars here that end up in the middle of another bar because that's just fucking retarded. It is unfortunately common in off-road, but not in this car. Everything is fully triangulated. So I don't know how they did it. They put up with me the whole time, and I still talk to the guy. He doesn't want me dead or anything like that. They did a phenomenal job.
He probably wants to see you out there doing something.
Yeah, I know. Lone Star Racing here in town. Really phenomenal. They have treated me so well. I even yelled at them one day. I'm not always the easiest customer, and they just want to do good work.
Yeah.
So yeah, I say nice things about them whenever I have a chance. So I don't know when this car is going to make it out, because I've got to have a place to race it where I actually want to race it. You know, I don't know when that's going to happen. No.
This could be your Yaw Power call out vehicle.
What do you mean?
Make it super badass and be like, you know, we own everybody. If anybody can beat me in this thing and anything, you win.
Well, the problem with that is in off-road racing, you have to say what? Like
Yeah.
you're talking about drag racing.
Yeah.
And maybe you say, well, it's the strip or the street.
Yeah.
But here it's like, where? At the
Yeah.
dunes?
Yeah.
Short course? Desert? It's all completely
There's so
different.
many different things.
I have considered turning this into a dune car.
Yeah.
The problem is that visibility is huge in the dunes. And I don't know if you see this or not, but being a full containment seat right there where it says Race Tech,
Yeah.
that's basically where his helmet is.
Yeah.
So visibility in this car is not great.
You're not seeing much out.
Might not be the best thing to take to the dunes. Yeah. This was all about a low center of gravity.
Gotcha.
So I don't know what's going to happen with it. Maybe I finish it up and sell it. I actually hate talking about it because I put so much into this car and now it's sitting, but whatever. Oh, 1 liter, one liter, 2-cylinder engine.
So this is the fuel depot over here.
Kind of. It's mostly it's just raw chemicals. Well, there's some batched fuels here, but
Well, it
mostly
turns into fuel eventually.
So I bring the cigar over here to do a leak test on the drums. Like, is it leaking? But it's just some of the basic. I mean, there are some mixed fuels here that get used regularly in the vehicles, but it's mostly chemicals that we use to batch the fuel. So they're labeled. I mean, that's toluene, ethylbenzene, isobutanol, methyl acetate, ethyl acetate, cyclopentane. This is some shit we call Happy 98. I'm not going to talk too much about what's in the fuels because it's stuff that I'm still working on, but ETBE, I think the drum next to it is MTBE. What the fuck is over here? It's just the basic components that we use to make shit. Isooctane,
And
methanol.
all this stuff is fairly stable as far as like how long.
Keep the lid on it. Yeah.
Yeah, it can stay here quite.
That's the big thing, is keeping the lid on it. Because you got to remember that gasoline, the reason gasoline is such a problem is it's not made out of pure hydrocarbons. These are all, to be fair, you know, pure means 100%, but these are all, you know, 97, 99 or more pure hydrocarbons, and they're not just going to turn to shit and oxidize sitting here in a drum.
Right.
Yeah. So, I mean, look, any good race gas, you can leave in a drum for, you know, several years and it's going to be fine.
Right.
If it's made out of shit like pump gas is. I mean, the biggest thing in pump gas is a group of hydrocarbons called olefins, and olefins react with oxygen and basically try to turn into sludge and rubber and shit like that. That's the biggest thing. But the reason they're in the fuel is that they make up, I think the limit on pump gas in the US is about 30%.
Mhm.
Well, imagine if somebody said you can't have olefins in your fuel because it's going to cause problems with long-term storage and things like that. It's like, okay, well, our gasoline supply just got cut in third.
Right.
Right? So, and by the way, as much as I hate pump gas for a performance fuel, it is a fucking miracle of science that they can take shit out of the ground and turn it into such a neat compound for so little money.
Yeah.
I mean, you think, oh, gas is expensive. It is, but when you consider what it is and what they've accomplished, it's one of those things that society has done where you're like, how the fuck did we accomplish this?
Yet they think that we need to get rid of it.
Yeah, well,
You know, that's the craziest part.
well, that's their job as government, is to fuck things up.
Got to get rid of it with your gay Tesla over here.
Oh, it's here.
Yeah.
Oh, that's right. Yeah. Hey, we should
What a disappointment this is.
we should probably go for a ride. I should just let it drive itself. And it's fucking weird. You have to keep your hand on the wheel or it gets pissed off and says, hey, and it'll shut off the self-driving.
Yeah.
But you can put in an address. If you weren't tired, I'd do it. And I would just punch in the address for the shop and we just let it drive us over there.
We
It's
can go
fucking
there
crazy.
if you want. That's fine.
I mean, it's not worth putting on video. Here's the problem with this car. The problem is that it's actually a really cool car.
Yeah.
The reason I say that's a problem is that because we have something that's somewhat viable, and I'm not talking about the infrastructure to charge them and all that, but we have a vehicle that's not a pile of shit. It makes it easy for the cocksuckers in government to say, you've all got to be emissions, zero emissions vehicles by 2035 or whatever.
Mhm.
If this car was a total ball of shit, they wouldn't be getting away with that. So I almost want to, Elon Musk, who I have a tremendous amount of respect for, I almost want to say, hey, would you knock this shit off and just focus on rockets? Because you're making life hard for the rest of us.
So let me ask you this, and I don't know from firsthand experience, but one thing I've heard more than once is, people love the cars, but they don't think like the build quality, interior, like fit and finish, not necessarily mechanically.
Yeah.
What's your opinion?
I was kind of worried. Well, I shouldn't say worried because it's Joanna's car.
Mhm.
It only mattered if she liked it.
Mhm.
But actually, it's surprisingly good. But I don't think people are full of shit. I think that the early cars were probably pretty fucking bad.
Yeah.
I think.
What year is this one?
This is brand new.
Oh, okay.
No, I mean, look, it's fucking nice, and you ride in it, and it's quiet. The ride quality's good. The stereo's good. Like literally, you know what? I should just let you drive it because you'll say, "Wow, this is a really nice car," and then you're mad because you don't want it to be nice. It's a fucking electric car.
Right.
That's how I am. Like, God damn it, I don't want this to be a good
That's how
car.
I feel when I see these cars at the drag strip, or even like the really super crazy stuff that's out there. That's millions of dollars right now. You know which car I'm talking about? The one out of Croatia.
Oh no, I guess I don't.
Oh, it's
Some electric fucking thing.
Rivian.
Oh, I didn't.
No,
know it was
not a
Croatia.
Rivian. That's a truck, isn't it? No, we'll talk about it later. But it's like a mid to low 8-second car.
Oh.
But it's like a supercar style. Like it looks like
electric motor.
yeah, it's all electric.
I want to hear it.
Yeah, and they did such a good job with it. Bugatti bought them.
Oh.
Yeah, so now they're part of Bugatti.
Unfortunately, it's a really good car.
Yeah.
And the other thing is that because, well, here's why I think it's a good car, and I think most of the rest of them are garbage. I don't think, look, take all the employees at Ford or General Motors or BMW and say, hey guys, aren't you excited about electric cars? They're like, no, just give me my fucking paycheck, right?
Right.
But this fucking whack job is all wound up about electric cars. He has a passion for it. He wants to build a cool electric car, so he did. But these other guys are just doing it because they're being forced into it. So
Right.
I wouldn't even consider at this point buying an electric car from any of the other manufacturers. I wouldn't get one for myself, but again, it's a surprisingly cool car. And I mean, I'm not into all their fucking fake environmental bullshit.
Yeah. I just saw a new
There's
one.
some neat things.
The Lucid Air Sapphire, which they're not the best looking cars, but
They got to be better looking than this.
yeah.
fucking
Well, it's
jelly
like more of a sedan, but it's actually faster than the Plaid now.
Oh, yeah, I did see that.
Yeah, it's pretty cool. It's just I like the fact that there's multiple players, even though obviously I'm a big Elon Musk fan myself.
I'm not.
So
I'm just not a fan of all this electric shit, only because it's being shoved down our throat.
yeah,
So this guy wants to build electric car. Fine. If you want to build it and somebody wants to buy it, it's none of my business.
right. Same with the Lucid Air. That's an electric car company. Those are different to me.
But when you're forcing people to build, like
you take a SUV, slap a Mustang logo on it, and make it electric, it's like, dude,
Fuck you,
you're
I don't-
fucking with us hard.
and nobody
right
wants
now.
it.
Yeah,
Nobody wants that fucking garbage. Yeah, if they want to build it and somebody wants to buy it, fine.
Yeah.
I just don't want it being forced on us.
And
I
this
don't
was,
buy their.
is this the car that you raced?
No, actually, this is funny, especially when you back up from a distance. Look at the difference in size between these two cars. This used to be Joanna's daily driver.
Oh, really?
Yeah, years ago, and then it's been on the track a little bit, but I don't know how familiar you are with Miatas, but they're actually pretty nice cars. They don't make any power, but they're nice.
I've
cars.
dynoed probably nearly 100 of them because
Oh, really?
I did the
shit of
dyno
a
check
motor.
at NASA.
Oh, okay.
And we did.
Oh, yeah.
We did it the national championships
Yep.
one year out in Utah, and just that race I probably dynoed 50 or 60.
They're really good cars.
Yeah.
Really well built. Yeah, I like them a lot. I don't fit in it, but whatever. Yeah.
I assume that's a wrap, right?
It is. And it's filthy because it's been sitting outside.
It looks cool though.
Yeah, it's a pretty neat car.
Yeah.
I like it. And unfortunately, so is the Tesla. It just is, like it or not. It's a good car.
Yeah. All right, Paul, let's wrap it up. I really appreciate you having me here at the business and here at your house. This has been really cool. We've known each other a long time, but I learned a lot more about you. And For those of you guys that I mentioned it earlier, we also did a podcast with Paul while we were out here. So make sure you check that out. The link is in the description. We talked for what, 3 hours, 3+ hours on all kinds of stuff. We even talked about politics, which was the first.
Hey, we didn't get in a fist fight.
No.
Oh, wait, that's because we agree.
That's because we agree. But, you know, we agree on a lot. So anyway, thanks for having me, and hopefully we can do it again.
Awesome.